Good morning, everyone. Welcome back. Nice to see a lot of familiar faces and some new friends as well have joined us for the session today. Today we're going to talk about finding STEM time on learning and teaching Common Core ELA and math with STEM content and process. We spent quite a bit of time at the end of the last session really talking about the practices and the processes. And I saw lots of light bulbs kind of go off around the room, and I think things became a little more demystified for folks as we made our way into the end of that last session. And we'll talk and reinforce that a little bit more today. What is your role in education? Are you an education student? Do you attend a local college? Are you a teacher, a principal, an administrator, or an other? Look at that. We magically have picked up people. 4 more people have walked in since the last question. That is remarkable. And let's see what our audience is comprised of today. So no students, good amount of teachers, principal, administrators, and then other. And others would be folks from nonprofits or after-school program time or organizations like Maritime Gloucester and things like that help support the missions of our local schools. So that's great. Did you come to the 3rd session of STEMsquared last month? Again, this just gives us a sense of who our audience is and how many folks have been here before. And as we talk about things today, we know what we want to kind of underline and repeat and things that we can maybe jump over a little bit. There are 5 of you out there still. This is a yes or no. All right, we're going to close that up. And, all right, so good. About 2/3 of folks have been here, and we have about 1/3 of folks that are new, so probably about 20 or so people who are new joining us, at least for this session. And then in terms of how many sessions have you been to, it's your first, it's your second, it's your third, or it's your fourth. 1, 2, 3, or 4 on your clicker. Today being the 4th. You guys are quick on that one. 67 in. All right, so let's take a look. So 31%, it's the first. 16 and 16, second, third, and then 36%, it's the 4th session. So good. So the 36% of you, will be counting on you to help guide some of our newcomers and our new folks when we're in groups and things like that. You kind of know what the expectations are and how these sessions sort of unfold and things like that. So we'll be counting on our veterans here to help lead the way when we go into some of those the group work that we'll have. So the next question, before you answer this one, one person, before you answer, think about this. I'm just curious, if you've been to any session, the first session, the second session, the third session, what's been, if you've had at all, an aha moment for you? Have you had something that you've sat here and it's really resonated with you, or you've walked out and you said, yeah, gee, that's something that I want to talk about in my class, or whatever the case may be, or maybe something at one of the site visits that we've taken. So have you had that aha moment? So either yes, no, or I have not attended a previous session. And then for the folks that answer yes, I'm going to actually ask a few folks to volunteer. What's been the aha moment? Has there been something that we have discussed that has particularly resonated with you as you've made your way through these sessions? So. Kind of a dangerous question, because if number 1 comes up as 0, I think Francis and I should probably pack up and walk out and say, thanks so much, have a good day. Okay, so, whew, my goodness. So 67% have had an aha moment, 3% no, and 30% have not attended a previous session, have been for folks. So just a real quick review. We're not watching this, but just for folks who are new, just to kind of implant things back into your brain. Congressman Tierney did a welcome message a couple of sessions ago. We've met with him, and he's interested in the work that's been happening here at STEMsquared, and he's certainly connected to North Shore industry in his role as a congressman, but certainly at the national level. We actually have another meeting set up with him later this month to kind of talk about our progress and to see, is there a way to kind of scale this up in a way? Is there a way to try to get this conversation going and continued to more and more people? So he's been a great supporter. and that was just a little clip from the welcome message he filmed down in DC for us. We talked about the state STEM focus, Governor Patrick, and the STEM advisory council that the governor has. So I think we really try to build that foundation of how important STEM is in our state. There's Kane, for those of you who remember our friend Kane. And that's him building his arcade out of plastic, rather out of cardboard. And that natural student interest that kids have, that sort of insatiable level of curiosity that we know that children have when they arrive at our classrooms every single day. And then also we spent some time talking about Bloom's taxonomy and how we really need our students to live up there, creating, evaluating, and analyzing. And these lower level thinking, this lower order thinking that is often prevalent in schools is certainly needed. You need the lower order to access the higher order, but if you're constantly living in that lower order world, we're not going to move the needle in education. If we really want to move the needle in education, I think if we can get our kids to live up there, we'll be better suited for it. And then finally, happiness. If you haven't had a chance to check this one out as well, write this one down if you are new to the session. Sean Aker. It's about 12 minutes long. And for those of you that have been here for other sessions and saw that, how many of you really enjoyed that video? Yeah. So there's some testimony from you. Paula, quickly share, because I love what you shared at the beginning.
How many of you have had to fill out some sort of web form where you've been asked to read a distorted sequence of characters like this? Yeah. How many of you found it really, really annoying? Okay, outstanding. So I invented that. Or I was one of the people who did it. That thing is called a CAPTCHA. And the reason is there is to make sure that you, the entity filling out the form, are actually a human and not some sort of computer program that was written to submit the form millions and millions of times. The reason it works is because humans, at least non-visually impaired humans, have no trouble reading these distorted squiggly characters, whereas computer programs simply can't do it as well yet. So for example, in the case of Ticketmaster, the reason you have to type these distorted characters is to prevent scalpers from writing a program that can buy millions of tickets two at a time. Now, CAPTCHAs are used all over the internet, and since they're used so often, a lot of times the precise sequence of random characters that are shown to the user is not so fortunate. So this is an example from the Yahoo registration page. The random characters that happen to be shown to the user were W-A-I-T, which of course spell a word. But the best part is the message that the Yahoo help desk got about 20 minutes later. This person. Person thought they needed to wait. This, of course, is not as bad as this poor person who... Okay, now, CAPTCHA project is something that we did here at Carnegie Mellon over 10 years ago, and it's been used everywhere. Let me now tell you about a project that we did a few years later, which is sort of the next evolution of CAPTCHAs, which is a project that we call reCAPTCHA, which is something that we started here at Carnegie Mellon, then we turned it into a startup company, and then about a year and a half ago, Google actually acquired this company. So let me tell you what this project started. Okay, so this project started from the following realization. It turns out that approximately 200 million CAPTCHAs are typed every day by people around the world. Okay? When I first heard this, I was quite proud of myself. I thought, look at the impact that my research has had. But then I started feeling bad. See, here's the thing. Each time you type a CAPTCHA, essentially, you waste 10 seconds of your time. And if you multiply that by 200 million, you get that humanity as a whole is wasting about 500,000 hours every day typing these annoying CAPTCHAs. So then I started feeling bad. And then I started thinking, well, of course, we can't just get rid of CAPTCHAs because the security of the web sort of depends on them. But then I started thinking, is there any way in which we can use this effort for something that is good for humanity? So see, here's the thing. While you're typing a CAPTCHA, during those 10 seconds, your brain is doing something amazing. Your brain is doing something that computers cannot yet do. So can we get you to do useful work for those 10 seconds? Another way of putting it is there's some humongous problem that we cannot yet get computers to solve, but that somehow we can split into tiny 10-second chunks such that each time somebody solves a CAPTCHA, they solve a little bit of this problem. And the answer to that is yes, and this is what we're doing now. So what you may not know is that nowadays, while you're typing a CAPTCHA, not only are you authenticating yourself as a human, but in addition, you're actually helping us to digitize books. Okay, so let me explain how this works. So there's a lot of projects out there trying to digitize books. Google has one, the Internet Archive has one, Amazon now with the Kindles trying to digitize books. Basically the way this works is you start with an old book, like a physical thing. You've seen those things, right? Like a book? Okay. So you start with a book and then you scan it. Now, scanning a book is like taking a digital photograph of every page of the book. It gives you an image for every page of the book. This is an image with text for every page of the book. The next step in the process is that the computer needs to be able to decipher all of the words in this image. That's done using a technology called OCR, for optical character recognition, which takes a picture of text and tries to figure out what the text is in there. Now, the problem is that OCR is not perfect, especially for older books where the ink has faded and the pages have turned yellow. OCR cannot recognize a lot of the words. For example, for things that were written more than 50 years ago, the computer cannot recognize about 30% of the words. So what we're doing now is we're taking all of the words that the computer cannot recognize, and we're getting people to read them for us while they're typing a CAPTCHA on the internet. Okay, so next time you type a CAPTCHA, these words that you're typing are actually words that are coming from books that are being digitized that the computer couldn't recognize. And now, the reason we have 2 words nowadays instead of 1 is because you see one of the words is a word that the system just got out of a book, it didn't know what it was, and it's going to present it to you. But since it doesn't know the answer for it, it cannot grade it for you. So what we do is we give you another word, one for which the system does know the answer. Okay, we don't tell you which one's which, and we say, please type both. And if you type the correct word for the one for which the system already knows the answer, it assumes you're human. And it also gets some confidence that you typed the other word correctly. And if we repeat this process to like 10 different people, and all of them agree on what the new word is, then we get one more word digitized accurately. So this is how the system works. And basically, since we released it about 3 or 4 years ago, a lot of websites have started switching from the old CAPTCHA, where people wasted the time, to the new CAPTCHA, where people are helping to digitize books. So for example, Ticketmaster, so every time you buy tickets on Ticketmaster, you help to digitize a book. Facebook, every time you add a friend or poke somebody, you help to digitize a book. Twitter, and about 350,000 other sites are all using reCAPTCHA. And in fact, the number of sites that are using reCAPTCHA is so high that the number of words that we're digitizing per day is really, really large. It's about 100 million a day, which is the equivalent of about 2.5 million books a year. And this is all being done one word at a time by just people typing CAPTCHAs on the internet. Okay, now, of course, since we're doing so many words per day, funny things can happen. And this is especially true because, see, now we're giving people 2 randomly chosen English words next to each other. Okay, so funny things can happen. So for example, we presented this word. It's the word Christians. There's nothing wrong with it. But if you present it along with another randomly chosen word, bad things can happen. So we show this. But it's even worse because the particular website where we show this actually happened to be called the Embassy of the Kingdom of God. Oops. Yep. Here's another really bad one, johnedwards.com. Okay, so we keep on insulting people left and right every day. Now, of course, we're not just insulting people. See, here's the thing. Since we're presenting 2 randomly chosen words, just interesting things can happen. So this has given rise to a really big internet meme that tens of thousands of people have participated in, which is called CAPTCHA art. I'm sure some of you have heard about it. Here's how it works. Okay, imagine you're using the internet and you see a CAPTCHA that you think is somewhat peculiar, like this CAPTCHA. Then what you're supposed to do is you take a screenshot of it. Then, of course, you fill out the CAPTCHA because you help us digitize a book. But then, first you take a screenshot, and then you draw something that is related to it. That's how it works. There are tens of thousands of these. Some of them are very cute. Some of them are funnier. And some of them, like paleontological schwizzle, they contain Snoop Dogg. Okay, so this is my favorite number of reCAPTCHA. So this is the favorite thing that I like about this whole project. This is the number of distinct people that have helped us digitize at least one word out of a book through reCAPTCHA. 750 million, which is a little over 10% of the world's population, has helped us digitize human knowledge. And it is numbers like these that motivate my research agenda. So the question that motivates my research is the following. If you look at humanity's large-scale achievements, these really big things that humanity has gotten together and done, like historically, like for example, building the pyramids of Egypt, or the Panama Canal, or putting a man on the moon, there's a curious fact about them, and it is that they were all done with about the same number of people. It's weird. They were all done with about 100,000 people. And the reason for that is because before the internet, coordinating more than 100,000 people, let alone paying them, was essentially impossible. But see, now with the internet, I've just shown you a project where we've gotten 750 million people to help us digitize human knowledge. So the question that motivates my research is, if we can put a man on the moon with 100,000, what can we do with 100 million? So based on this question, we've had a lot of different projects that we've been working on. Let me tell you about one that I'm most excited about. This is something that we've been sort of semi-quietly working on for the last year and a half or so. It hasn't yet been launched. It's called Duolingo. Since it hasn't been launched, shh. Yeah, I can trust you with that. Okay, so this is a project. Here's how it started. It started with me posing a question to my graduate student, Severin Hacker. Okay, that's Severin Hacker. So I posed a question to my graduate student. By the way, you did hear me correctly. His last name is Hacker. So I posed this question to him. How can we get 100 million people translating the web into every major language for free? Okay, so there's a lot of things to say about this question. First of all, translating the web. So right now the web is partitioned into multiple languages. A large fraction of it is in English. If you don't know any English, you can't access it. But there's large fractions in other different languages, and if you don't know those languages, you can't access it. So I would like to translate all of the web, or at least most of the web, into every major language. Okay, so that's what I would like to do. Now, some of you may say, well, why can't we use computers to translate? Why can't we use machine translation? So machine translation nowadays is starting to translate some sentences here and there. Why can't we use it to translate the whole web? Well, the problem with that is that it's not yet good enough, and it probably won't be for the next 15 to 20 years. It makes a lot of mistakes. Even when it doesn't make a mistake, since it makes so many mistakes, you don't know whether to trust it or not. So let me show you an example of something that was translated with a machine. It was a forum post. It was somebody who was trying to ask a question about JavaScript. It was translated from Japanese into English. So I'll just let you read. This person starts apologizing from the fact that it's translated with a computer. Okay, so the next sentence is going to be the preamble to the question. So he's just explaining something. Remember, it's a question about JavaScript. Okay. Then comes the first part of the question. Then comes my favorite part of the question. And then comes the ending, which is my favorite part of the whole thing. Okay, so computer translation, not yet good enough. Okay, so back to the question. So we need people to translate the whole web. Okay, so now the next question you may have is, well, why can't we just pay people to do this? We could pay professional language translators to translate the whole web. We could do that. Unfortunately, it would be extremely expensive. For example, translating a tiny, tiny fraction of the whole web, Wikipedia, into one other language, Spanish. Okay? You know, Wikipedia exists in Spanish, but it's very small compared to the size of English. It's about 20% of the size of English. If we wanted to translate the other 80% into Spanish, it would cost at least $50 million. And this is even at the most exploited outsourcing country out there. Okay? So it'd be very expensive. So what we want to do is we want to get 100 million people translate the web into every major language for free. Okay? Now, if this is what you want to do, you pretty quickly realize you're going to run into two pretty big hurdles, two big obstacles. Okay, the first one is a lack of bilinguals. Okay, so I don't even know if there exists 100 million people out there using the web who are bilingual enough to help us translate. Okay, that's a big problem. The other problem that you're going to run into is a lack of motivation. How are we going to motivate people to actually translate the web for free? Okay, this is normally, you have to pay people to do this, so how are we going to motivate them to do it for free? Now, when we were starting to think about this, we were blocked by these two things, but then we realized there's actually a way to solve both of these problems with the same solution. There's a way to kill two birds with one stone. And that is to transform language translation into something that millions of people want to do, and that also helps with the problem of lack of bilinguals, and that is language education. Okay, so it turns out that today there are over 1.2 billion people learning a foreign language. People really, really want to learn a foreign language. And it's not just because they're being forced to do so in school. For example, in the United States alone, there are over 5 million people who have paid over $500 for software to learn a new language. Okay, so people really, really want to learn a new language. So what we've been working on for the last year and a half is a new website. It's called Duolingo, where the basic idea is people learn a new language for free while simultaneously translating the web. And so basically, they're learning by doing. Okay, so the way this works is whenever you're just a beginner, we give you very, very simple sentences. There's, of course, a lot of very simple sentences on the web. We give you very, very simple sentences along with what each word means. Okay, and as you translate them and as you see how other people translate them, you start learning the language. And as you get more and more advanced, we give you more and more complex sentences to translate. But at all times, you're learning by doing. Okay, now the crazy thing about this method is that it actually really works. Okay, first of all, people are really, really learning a language. We're mostly done building it, and now we're testing it. People really can learn a language with it. And they learn it about as well as the leading language learning software. So people really do learn a language. And not only do they learn it as well, but actually it's way more interesting. Because you see, with Duolingo, people are actually learning with real content. As opposed to learning with made-up sentences, people are learning with real content, which is inherently interesting. Okay, the other thing, so people really do learn a language, but perhaps more surprisingly, the translations that we get from people using the site, even though they're just beginners, the translations that we get are as accurate as those of professional language translators, which is very surprising. So let me show you one example. This is a sentence that was translated from German into English. The top is the German. The middle is an English translation that was done by somebody who was a professional language translator who we paid 20 cents a word for this translation. And the bottom is the translation by users of Duolingo, none of whom knew any German before they started using the site. If you can see, it's pretty much perfect. Now, of course, we play a trick here to make the translations as good as professional language translators. We combine the translations of multiple beginners to get the quality of a single professional translator. Okay, now, even though we're combining the translations, the site actually can translate pretty fast. So let me show you, this is our estimates of how fast we could translate Wikipedia from English into Spanish. Remember, this is $50 million worth of value. Okay, so if we wanted to translate Wikipedia into Spanish, we could do it in 5 weeks with 100,000 active users, and we could do it in about 80 hours with 1 million active users. Since all of the projects that my group has worked on so far have gotten millions of users, we're hopeful that we'll be able to translate extremely fast with this project. Now, the thing that I'm most excited about with Duolingo is that I think this provides a fair business model for language education. So here's the thing. The current business model for language education is the student pays. And in particular, the student pays Rosetta Stone $500. That's the current business model. The problem with this business model is that 95% of the world's population doesn't have $500. So it's extremely unfair towards the poor. Okay, this is totally biased towards the rich. Now, see, in Duolingo, because while you learn, you're actually creating value. You are translating stuff, which, for example, we could charge somebody for translations. So this is how we could monetize this. Since people are creating value while they're learning, they don't have to pay with their money, they pay with their time. But the magical thing here is that they're paying with their time, but that is time that would have had to be spent anyways learning the language. Okay, so the nice thing about Duolingo is I think it provides a fair business model, one that doesn't discriminate against poor people. So here's the site. Thank you. So here's the site. We haven't yet launched, but if you go there, you can sign up to be part of our private beta, which are probably going to start in about 3 or 4 weeks. But we haven't yet launched this Duolingo. By the way, I'm the one talking here, but actually Duolingo is the work of a really awesome team, some of whom are here. So thank you.
Before Francis leads a quick discussion on this, just 2 quick thoughts that struck me. The first of which is it made my angst over trying to clean a closet during the holiday break seem quite minimal. You know, I was like, oh my God, how am I going to clean this closet? This guy wants to translate the entire web, right? And then the second great thing for you, this is a really good piece of news for you, is that, so now I had watched this video, and I was in the office at home, and I was on Ticketmaster. My wife walked in, and she said, what are you doing? I said, I'm working. I'm working. I'm working. I'm buying tickets, but I'm actually working. So Francis will lead a little discussion about this and kind of collect some thoughts and make some connections for you.
So, I guess first of all, what's your impression? What do you think of this guy's work between the reCAPTCHA and Duolingo? It's pretty dynamic, isn't it? I mean, here's somebody taking a bunch of people, 2 seconds, 10 seconds, punching in, but creating value out of it. The thing that really struck me is that when you think about this chart, what's the bike that he's creating? You know, if you think about Steve Jobs saying that it was so clever, and in this case, there's a car, right? And they talk about the speed limit on the motorway in the UK is 70 miles an hour. That car actually can make people much faster than the cheetah if it doesn't drive the speed limit. So if cars serve a purpose in getting us someplace faster, create value that way, what's the car in the case of the translation? Well, the people are doing the translation, right? It's the internet. It's that platform that he created. That website is the car. Recapture is the car. People are working it. It's creating value by teaching somebody a language, translating a website, translating a book. But without that, I mean, it's astonishing. I don't know how many of you use Wikipedia. I would think everybody has bumped into it at least more than once. It's just unbelievable that they could translate all of Wikipedia in 80 hours with 1 million people. I mean, 80 hours is nothing. So one of the things I guess I wanted to think about too is that if we try to fit this into the idea of engineering, we were talking about scientific processes and engineering processes. How does this fit the model of engineering we've been talking about? And so if you haven't been here before, I guess we maybe could zip ahead a slide or two and kind of take a look at that. I guess maybe we start here. How is what Lewis is doing involving practices? So how is it STEM knowledge and technology it's not just the content. He's a computer scientist, right? He can code, so what? It's not just the skill. I mean, he's good at it, right? He's able to get research funding. That's great. How is it the practices applied to a discipline? How is what he's doing practices applied to a discipline in sort of a novel way? Yeah.
Well, he's working, somewhere he's working the world for programs, et cetera, but he's applying a specific challenge of how to do translation, how to do digitizing, and he's come up with a way, efforts of many imperfect translators or whatever to
Exactly. So he's taken the content, the how to code, the whatever, the skill of being able to do it well, but he's taken it to solve a problem, that problem of translation, that problem of something else. So if we kind of move forward a little bit, just to catch people up who haven't been here before, a process is taking practices, and I can show you a list of practices, and basically putting them into specific order to achieve a goal here. So in the case of science, you're answering a question. In the case of engineering, you're identifying a problem. Was he doing science or was he doing engineering through his work? Engineering. Why engineering? Yeah, he identified a problem. What was in the case of recapture, what was the problem? Recapture is the one where it verifies if you're human. Okay, the computers aren't good enough to digitize books entirely, but someone said it over here. Wasted time. That was the problem. People are wasting, and I can't remember what he said, 500,000 hours or something like that a day, or a week, or whatever, cumulatively, punching nothing into a computer. But if that nothing was something, if we could solve the problem of the wasted time, then suddenly we might be able to solve this problem, kind of two problems. One, the wasted time. Two, the computers are not good enough to read the faded print optically. And so that's where the foundation of his research, looking at other technologies, but then developing a prototype. Okay? So in the case of a computer solution, the materials you have really is around things like bandwidth, processing speed, not so much popsicle sticks and certain types of metal. When it came to testing the prototype, just kind of thinking through this, he's not describing it. What sort of a test is he doing? What did he do?
You mentioned the beta testing at the end. You mentioned that they were not opening the website for people to start trying it and see how well they were. Obviously, they have certain
Right. Well, in the case of the Duolingo, they probably tested this, reCAPTCHA, they tested this in like an environment with a small group, maybe a group this size. But what they actually do is they eventually launch the site. And they watch the data, and they try to figure out if they have to change the way they've structured their code or structured their incentives to be able to make, the data they gather, it's informing that solution. So improve their prototype, iterate it in some way, and then eventually either replicate it, or in his case, he's talking about monetizing it. Could he actually charge people to translate documents and then have other people learn to speak a language for free? One of the things that kind of struck me as we're kind of talking through this is that, he's translating one language to another. That's not really computer science. So I guess we would say that's sort of reaching into ELA. You might say that that's reaching into foreign language. The other thing is that he's involving math. Where is he involving math? You might have caught this. He said it a couple times. Exactly. People make mistakes, or people misunderstand. But if we ask 100 people the same question, and we get 75% of the people who agree on an answer, chances are that's the answer. We can mathematically pull something out of that information and then rely on it with some confidence to put it into a book. So now we've got ELA, foreign language, math. The president of Montserrat College said to me, we were talking about, and someone actually here came up and was saying, what about STEAM? And STEAM's a big thing people are talking about right now. And we're going to talk a little bit more about this later. Art is highly engineered communication. It's what it is. Anybody who's got a piece in a museum, more or less, has communicated something with high impact, and that's what made them famous. So as you kind of look through this, and Picasso's a famous one. There was problems, political problems at the time he was living, and things that he had identified, and he used art as a way of communicating his feelings and to his peers about certain challenges, and was able. The materials that were part of what he was using was not only paper, or not paper, I guess in some cases paper, but paint and canvas, but also a material that he's using was his things that are less tangible, his network, his fame, different things like that, connection to certain political figures. And you could go through and you could actually create an engineering sort of model using the engineering process to go through and actually look at the effectiveness of that. And you could draw conclusions. It wouldn't be sort of black and white conclusions, but you'd be able to form an argument. So I thought it was really interesting how he started with that waste of time problem and then moved on to solution translating books, testing the reCAPTCHA, and then essentially ending up with a solution, and the product of the solution was translating 2.5 million books a year, which are probably some of the core early literary pieces. And the social problem that he's solving here, especially in the case of Duolingo, so if you kind of go that way, when he's saying, not everybody has $500 a year to pay Rosetta Stone. So what is the social problem that he is solving through Duolingo?
By providing it for free, he's giving the opportunity to access it right now with money.
Exactly. So if you think back to that chart that we had, the bike. He's now, through the technology, he's actually giving people a bike that couldn't otherwise afford one. And that tends to be the way things start, right? Bikes are for people who can afford them, and eventually, if it's something that's really worthwhile that people need, it can be made more cleverly like he's doing. So anyway, so that's, I guess, some of my initial observation. I don't know if there's anything.
Yeah, I would just say with these slides, with these two slides, I mean, this is really the crux of where we were when we ended the last session. We were really talking about those practices, and when you order those practices in a certain way, oh, look, you get the scientific method. And when you order those practices in a different way, oh, look, you get the engineering design process. And I think that was, the bookmark you got last time. I think we had that right on there, the method on the front and the engineering design process on the back. And this is really the crux of what we're talking about. When we talk about STEM, and there's a slide a little bit later on that talks about this, but STEM is just an acronym. That's all it is. It's nothing more than that. It's just science, technology, engineering, math. Someone just decided to put the first letters of those 4 words together, and it made STEM, and now you see STEM everywhere, and everyone talks about STEM, and STEM shows up in every single email, and it's like STEM has become this sort of big amorphous thing, like what does it really mean? STEM is a way of thinking. That's what it is. In those subject areas, the glue in those subject areas is that way of thinking. In science, technology, engineering, and math, there is a certain analytical way to think, then a certain process to follow that kids use to solve a problem or to answer a question. That's all STEM is. And so the more we can build that into our day and into the routine of what we do in school, the better served we'll be in terms of preparing kids for the 21st century. We keep hearing that we have to do that. Well, how do we do it? We get kids to think in this practice, process-oriented way. That's what will do it. We talked about this when we made those site visits. The people who are in those buildings and working every single day, they can't just skip a practice. They can't say, I didn't feel like doing that step in the practice or the process today. They don't have that ability. That'll mess up the whole final product. And so that's a big part of what we talked about last time. And really, building off those NRC, the National Research Council STEM practices, this is what we have as our STEM practices. And you look at these and you put them in a certain order, and yes, you get your scientific method, engineering and design process. And this is inherent in the work that we do.
Think about that. Just think about that mathematical situation where you're taking those recaptures, right? One that's known, one that's not known, and you're comparing the results from different people, right? That's a process. And you've established a certain threshold that when, let's say 75% of the people agree, that then gets entered as what the word means and into the book. If you violate that process and you only do it once in a while, does that affect the outcome? It does. That actually is the situation that is coming up with the Duolingo, right? You have a machine that can translate things, great, but it's unreliable. And look at the outcomes. And so, that's something that has to be worked on. If you can create a process and you are sticking to that process, you have sort of and it's easy with things like computer science because it's just machines. But you create that expectation and you create that definition, which then is really a part of sort of the quality aspect of what you're doing. Yes?
One thing that, theme that I'm seeing when you look at the last slide about the 2 processes is the importance, especially on the engineering design, of the last number 8, because of refine or replicate. Because I'm seeing, like, when I went to the analogic, or the guy that we just saw on the video, when they create whatever it is they create, they're so curious to make it better. And it's that curiosity, I feel, that's leading them to their success. Because he could have stopped at capture or at analogic. He could have stopped at creating an X-ray that's just 2-dimensional. But they're always trying to refine it and make it better. And I think that comes across in our classrooms. It's so important to keep the kids curious. Like, if we solve a problem, there's always more. You can always take it further.
Absolutely. Yes?
Bill, even before that, I was amazed that of their curiosity and their creativity and seeing that 10 seconds of wasted time as something that could be used, and then to think about how to use it and digitize books. I mean, making those connections seem outside of the box, and how important it is to continue to cultivate that style of thinking in the classroom.
Did you have that when I first watched that video? I couldn't even get my head around it. Like, what? We're going to translate. You've got 1 million, 10 million people translating books. Like, how do you even begin that? Well, you post a thing on School Spring? Like, how do you even begin that process? And don't think out of the box. We've got people on computers using the same thing all the time. So I get 1 million people to do 10 seconds of work. Genius.
But it was something that, it's just a little annoying
exactly.
But it was like, yeah, I can use this as a big deal.
Right.
It's like, what?
And there's something about 10 seconds, right? If that took 3 minutes, that'd be very annoying.
Yeah, right.
People would be, oh, this is crazy. I'm not buying the ticket from this company because I'm on this site for 3 minutes.
And often the people who think like him are the kids who struggle the most in our regular school curriculum because they're thinking outside the box all the time and we're trying to cram them in. And if we had a system that sort of let them go a little more because we were teaching that way, because we were saying, well, let's solve the problem in lots of different ways, those kids would excel.
Agreed. Agreed.
And I think it's like dissolving those walls between disciplines, because when you, like in this guy's case, if he said, you know what, I'm a computer scientist, what I do is program. So then he sits there able to program, but what does he program?
Right.
Video games? I don't know. Just whatever you program without a purpose. But in his case, he's looking at it and he's saying, people are wasting time using what I've created. How can I make that time valuable? So they started thinking of it. I'd love to know what he thought of that he didn't do. Like in this case, it's translating books. Who knows what other things he thought about? I know I've seen some with math problems. I'm not sure if those are maybe for math texts or something. Who knows? But that's just it. And the thing is it's because he's a master of the practices and the processes, and he sees those as having value outside of just computer science. And that's what today's all about, is that the fact that ELA, STEM processes and practices have value outside of STEM, because STEM is just an acronym. It's a bunch of things lumped together. Just like STEAM, you can add art in there. Well, you know, actually, we need to add history, social studies,
STEM,
all these things need to be
ELA.
added
I mean,
in.
it could become this giant acronym. It really doesn't matter that it's STEM. It's this is what's important.
And it comes back to the practices and processes, because that's the core. And we're going to talk about some of that with UBD in a little bit.
You know, I think even Cain, right? He saw wasted cardboard. I mean, you could put it at a 7-year-old level. He saw wasted cardboard, and he was creative, like this gentleman was creative. And can I find a different use for this? Can I think out of the box, so to speak, and think differently? And I think the way we get kids to think differently is allowing them to access higher order thinking, right? Is allowing them to internalize this process of here's how you can solve something. Here's how you can think through something. I love those 2 stories Francis told, and I think he's probably telling them again today about the duck and the boy fishing, right? Those are great, great stories. He'll repeat those again at some point today for folks who haven't heard them, but they fit within this whole thing that we're talking about. All right, so similarly in writing, right? I mean, you have writing practices that you follow. There's a process for writing, right? So there's a process for science. There's a process for engineering. There's a process for math. And so in our writing practices, we know that there's ideas and voice and word choice and sentence fluency. And when you put these practices together, it comes together as a process. So if you need to make connections for the teachers back in your school, say to them, you're already doing this. You're using practices and turning them into a process. And STEM is just the same thing. STEM is taking effective practices that we know work and having kids think in a different way and putting it into a process that allows them to solve a problem or answer a question. So success in STEM relies on teachers and students internalizing those practices, internalizing the process, and asking the focused question. Francis is going to talk to you a little bit about asking the right question, because that's another important component of the work that we do. And how do we get kids to effectively use these practices and effectively use these processes? And the way you do that is you have to ask the right question in order for that to work.
Yeah, so this always comes up. So if you notice, the scientific process always starts with a question. In the case of the engineering process, what does it start with? A problem. So if you have a question, you're in the science side. If you have a problem, you're on the engineering side. But what we often see, especially where this is most visible, is people start to kind of use these processes. They frame, and I'm using science as an example, they frame the question too broadly, or in a way that's not particularly scientific. So you see the ones that are not particularly scientific more with students in science fairs. So you'll have a student come to you and say, what's your question that you're going to try to answer? And they'll say, oh, can I build a circuit? And it's like, well, I don't know. But that's not what we're going for. So in this case, I think those are fairly obvious. But in this case, I see teachers get stuck here. So here's a question with too many variables. Why do people lie? Huge number of variables. Is that something that we could answer in our classroom? No. And lying, we probably could pick something else, but you want to constrain the variables and also constrain the question to something that you could answer. So do people lie more when stressed? So if we were researchers in psychology department or something like that, we wouldn't be able to answer why do people lie, but we could answer the question, do people lie more when stressed? Because we can actually create an experiment. We can control that experiment. We can isolate the variables. Doesn't mean that there's only one, but we can isolate. In this case, there's one, the stress variable, and test for it, gather data, and form some conclusion that reflects on our hypothesis whether stress has an impact or not. One of the kids, will come, or sometimes you see questions like, why is the sky blue? Great question. Could that be answered? Sure. Can that be answered in an elementary classroom with the typical tools and resources of an elementary classroom with an experiment? No, you can't, not typically. You can go research about it, but it's going to be very hard for you to collect data. Other kind of questions that come up, why, somebody came up and asked a question one time, and they said, I have a kindergarten or a first grade class, really young group, and they said, we're trying to answer the question, why are there 2 high tides a day? I said, well, that's difficult. So the thing is that while it's something that you could do research on at a higher level, at an elementary level, explaining that the moon doesn't orbit the Earth twice a day. There's a tidal bulge on one side, and the moon's gravity. I hope I said the moon orbits the Earth. Maybe I said something else. The moon doesn't orbit the Earth twice a day. You get into all of these abstract things. It's not particularly accessible. So as you're framing questions, you have to think about the variables, the number of variables, and then whether you have the resources and whether it's actually accessible to the students or if it's too abstract. And that, unfortunately, takes practice, because sometimes you think you've got limited variables and that it's accessible, and then you realize, wait a minute, even though we all have seen the moon, we all know the sun comes up twice a day. Sun comes up once a day and sets once a day. It's still not enough, okay? So that's focusing the question, in the case of framing the problem. So in his case, in the case of the recapture, the problem was that people were wasting their time. So his problem wasn't so much translating books, it was people wasting their time. So translating books and using recapture was actually a possible solution. It was actually further down the chain in the engineering process.
I think this would be a good spot to just tell that quick duck and boy fishing story again, because I think when we internalize the practices and internalize the processes, that will change the way you function in your classroom and change the way the kids function in the classroom. I think that's one of the biggest things that we hope you take away from these sessions, that we sort of need to demystify STEM and debunk the myth around STEM. Like, people think STEM is this big amorphous thing that you can't get your head around. And it's really a way of thinking. That's all it is. It's an acronym of those subject areas, and the glue that holds those subject areas together is a particular way of thinking. And guess what? That particular way of thinking can be translated into other subject areas that you can use to get kids to constantly reinforce that way of thinking. So, the duck and the kid fishing story, obviously the duck's not going to be able to internalize the process, but right. the kid could have.
Right. So in the case of the duck and the kid, so I was looking out my window one day and I saw these ducks. It was actually kind of like this time of year. There's some ducks in this canal, and somebody had tossed a bunch of bread in, and the tide was going out, and the bread was dumped over here, and it was sort of sucked out underneath the dock, and then it was kind of going down. And on the other side of the dock, there was a bunch of ducks fighting each other for the food. And this food was coming out this little narrow opening, and they're fighting, and they're fighting, and they're fighting, and they're fighting. And I thought to myself, if the ducks had realized that the food was coming from the other side, it was all over the place, they all would have had their pick of whatever they wanted, no competition. And I thought, well, that's what makes them ducks, right? They don't have a bike. Later on, like 6 months later, I see this little guy get out there every couple years. See him, he gets off the parents' boat. It's summertime now. Gets off the parents' boat on the dock, got his life jacket on. Parents are sitting on the boat having a drink. And he's out there with his fishing rod, and he's casting the fishing rod out, and he's reeling it in as fast as he can. And he probably did this for like an hour or maybe even longer. Every time, the same way. Cast it out, reeled it in. Cast it out, reeled it in. Cast it out, reeled it in. Guess what? Didn't catch anything. And I thought to myself, if he had wondered, he had the question, why am I not catching any fish? Or are fish, anything about the nature of the fishing that he was doing? He would have been varying. He would have been casting it out with different speeds. He would have cast it out in different places. He would have reeled it in at different speeds. He may have changed the bait, maybe the lure, whatever he was using. And so when you kind of go back to and this is where it starts becoming more complex, when you go back to those practices, they actually might be a little bit forward. Here we are. He wasn't developing and using any model to understand his question or his results. He wasn't carrying out any investigation. He wasn't analyzing and interpreting the data, right? No fish, no fish, no fish. Keep doing the same thing. Keep doing the same thing. The mathematical and computational thinking would be, well, if I cast it out, in a different spot, is this spot have more fish, or if this speed attracting fish to the lure, those sort of things. None of that was happening. So in essence, I kind of saw the kid and the ducks, and I went, gee, they're kind of both having limited success because they're not changing anything up. They're not approaching what they're doing with sort of that habit of mind of a scientist or an engineer. And so there was sort of no variables. There was no question, there was no variables, and you end up with kind of poor results in both cases.
Yeah. Good. So again, just to kind of underline and score that point, again, it's held together. STEM is held together by the practices and processes. And these practices and processes can be applied in all other areas. You can use these practices and processes in other subject areas that will continue to help your kids access that way of thinking that they need in order to be analytical, higher-order thinkers that we need them to be. I think back to the point our friend in the back made there about all these people from the workforce who came out because, yes, we need to be sending off our students onto the middle grades and the high school grades and the college grades with more of these skills, and it all starts now. The kids in elementary school are able to think in this manner. So this doesn't have to be a big mystery about what is STEM. It's literally just a way of thinking, and we can apply that way of thinking to other areas of our school day. So time on learning.
So some things with time on learning. So if you're thinking about Common Core ELA and math and even social studies and other areas, art, we could create a circle for each of these different disciplines, and they would all overlay with each other, right? Kind of Venn diagram. In the case of science, and we can lump in engineering and technology in there too, science requires nonfiction reading. It requires writing. It requires analysis. Depending on the type of analysis you're doing, that could be ELA. It could be math. You're doing data collection, calculation, graphing, all math. The only thing that's really science or engineering or whatever, technology, is the experimenting, the prototyping, and we haven't talked really much about technology in the sense of what technology is. Technology is what solves the problem. The reCAPTCHA, that was the technology. The bike, technology. The car, technology. That's the product. That's it. It's not that it plugs in, okay? Not electric, necessarily. So the experimenting and prototyping process, that's what science. Everything else belongs someplace else. So really, if you pull science out and make it all on its own, you've lost value in math and in ELA. right? By being able to do two things at one time and creating a more rich set of connections. But at the same time, you're creating time on learning issues for yourself, because to really do this effectively, you're spending several hours a week among these things, okay?
Good. So before we get to the next section, in 20 seconds, I'm going to ask you to stand. And after I ask you to stand, what I'd like you to do is just turn to a partner, group of 2 or 3, turn back, turn side to side. What's resonating right now? What are you thinking about? What's in your brain? What connections are you making? So let's stand, turn, talk, and we'll do a quick share. Anyone willing to share some things that are resonating with you or connections that you're making? What would you talk about in your group? Yes.
We talked about many things, but one thing was how that we will capital to. Why couldn't we apply that in the classroom? Why couldn't we bodies in front of us or whatever age they are, and use when they're solving problems with the school, writing about things that are important to them instead of this handed down curriculum.
Authentic learning.
Yeah, thinking about it differently.
Right.
We can think about it on that level. We can think about it on the level we are, where we are.
Absolutely. Right. You've got 20, 25 students in your class. Can they do some sort of massive online, not online, but massive collaboration that helps to solve a problem that, guess what, would bring in science and social studies and math and ELA and real, authentic learning. And he made that point, the gentleman, when he talked about the dual language, he made the point that the people who have no training are doing it just as well as the people who have training. Why? Because it has meaning. Right. It's not a random sentence, I walked the dog in the park. It's information I wanted to go read on Wikipedia anyway to go learn something. And oh, guess what? By the way, here's a great byproduct. Absolutely. Agree 100%. Others, what else is resonating?
And that gives them a little,
Yeah.
they get a little excited.
Correct.
Well, and I think that really, I think part of, and this is what we need to probably move on to here quickly, is, you're articulating a problem. And the problem is that a lot of what we teach, I mean, the foundations of it have been known for thousands of years. But if you think, and I guess my classic example of that is igneous, sedimentary, and metamorphic rock. I mean, as old as the age is, right? And yet, the way we approach it's like, oftentimes, is like the kid on the dock, right? Again and again and again and again and again. And we know the result. And that's what's creating this problem. How do we solve that problem? We can't eliminate the standard. It needs to be known. But the thing is what does sedimentary, igneous, and metamorphic rock relate to? What's it a part of that's exciting? It's exciting that people are engineering that stone for countertops. I find that a little bit interesting, the way they're doing that, the way they're culturing stone. I find it interesting, the types of stones, even the origin of concrete and what concrete allowed us to accomplish. And that leads us into history, to people like the Romans, who really, made use of the arch and perfected many things as engineers. Romans didn't invent much. The Greeks did. The Romans re-engineered it. So that's the thing. I think as we internalize these processes and practices ourselves as educators, I think that we need to be thinking as scientists and engineers about our curriculum. I got this old as dirt standard. What is it? What is it that it's a part of that's interesting, right? Scratching it on a brick or on a clay tile is not particularly interesting. But if we can relate that to what makes it relevant. So for instance, why would you use this? Why do people even care about having this for a countertop? What makes it desirable? What can we infer from the characteristics of these minerals and rocks that make certain types of rocks better and more desirable for building than other rocks, for countertops, for jewelry? Why are diamonds even valuable? Why are natural diamonds valuable and unnatural man-made diamonds relatively less valuable. These sort of things. So anyway, so I don't want to go off on that too much, but I think that that's really at the core of this, is that it's that sort of kid on the dock issue that faces us, and it's a communication issue because, we feel it, but do the people above us know we feel it? Are they enabling us? Because that's the thing, is if we're not enabled, we're still pretty stuck, if you've got to do both.
I think the better slide right now, I just jumped 3,
Sure.
is this one, because this kind of fits with the conversation right now.
Sure, so we're talking about that. So,
We're having turkey for lunch.
Scott, turkey for lunch. Happy Thanksgiving. Scott was saying, well, how do you really use something like, what do you say, like the scientific method?
Yeah, how do we get kids to think this way in other subject areas?
Yeah, how do we take like the scientific process and these practices and apply them in something like social studies? I said, I said, well, it seems like every time someone's doing social studies, they're doing something about the Pilgrims. It's like, what's with the Pilgrims? And I said, well, here's an example. I read an article talking about the Pilgrims, and when they they first landed, they landed in Provincetown. And you might be learning about this in your class, that they landed in Provincetown before they settled, made their way on and settled in Plymouth. And being scientists, our habit is to ask questions. What's the question? If you just came across the ocean and you land in Provincetown, why wouldn't you stay there? Why move on? So there's your question. What sort of research would you do about it? Time of year may be a factor. What were the time of year? What were the conditions that year? What were the resources available in
Based
Provincetown?
upon their needs that they had.
What else would you ask? What was the landscape like? What had happened in that area historically? We could do all this research. And what sort of hypothesis might we form from the research? What would be an example of a hypothesis we might form? This is all social studies, by the way.
Inhabitable? They found it to be inhabitable based on weather, conditions, landscape, resources.
Okay, so now let's constrain our variables, but you're right. I shouldn't say right, but you're on the right track. It had to do with the weather, had to do with the conditions. Maybe you discover that the Pilgrims were farmers. Maybe they had some bias about the type of landscape and soil that was there and the sort of things that they were accustomed to growing. Maybe they felt like it wasn't a great place to settle because they knew the importance of food, and so it had to do with the soil. So whatever it is, the Pilgrims did not settle in Provincetown because of the soil.
Did they stay in Provincetown for half a year? Answer that question. Then move on.
Okay, you could go that way. Why did they stay in what was in Provincetown?
Right.
Were there facilities to fix ships? Were there any populations? Exactly. So you can go with this. Now, take it a step further. So that's just, you got to a hypothesis. What sort of experiment could you do off of this? You could simulate or recreate elements of the environment. So if your hypothesis was that they moved on because of the soil type, what you would want to do is you want to structure an experiment that took a comparable sample of soil from Provincetown and compared it to the type of soil in Plymouth and maybe grow the crops that they were accustomed to growing or something like this. So you would be constraining and to see which one has the better soil for the type of crops that they would have lived on. And so maybe you can infer something from that data that would either support or disprove your hypothesis.
So if you're a pilgrim, what would you do?
Exactly. If you were
Yeah,
a
you're
pilgrim,
writing
what would you
about
do?
it.
So
Right.
that's the thing, is like, it's not necessarily sort of like, why do people lie? We can't say, why did the Pilgrims move? But we can say, essentially, we can come to a hypothesis off that question that says, is the soil better for growing in one place than the other? And we can start to build a body of knowledge around it and build a case for why they would not want to settle in Provincetown and they would want to settle in Plymouth. So those are all, that's a scientific process, right? Going through the procedure materials for setting up the test, the soil, the types of plants, the conditions, everything, your controls and your variables. diagramming how that operation works, collecting the data, right? You're going to probably do multiple trials, and then coming to some sort of a conclusion. And then you're probably going to ask other questions that are related, or actually forming other related hypotheses and begin to build that knowledge. So that's all social studies.
So the content was social studies, but the car you used to drive there was this way of thinking, right?
In the days when I was in middle school, we were taught subject matter because it was subject matter that we were supposed to learn. Today we teach, or should be teaching, subject matters, and why that subject matter is important should be realized by the students.
Mm-hmm.
So what and wherefore of the subject matter is more important than the subject matter itself. That makes sense.
So you're saying that
Lost me at the end.
the way you think about it and the thinking, processing of the subject matter is more important than the subject matter itself.
Right.
Okay.
Why it's important, why, and same thing for math. Okay, 2 times 2 is 4, 4 times 4 is 16,
Right, and on and on.
Stuff. I didn't realize until I was in high school what a square was, and why 2 times 2 is called 2 squared.
Right.
Right.
Kids can get that in third grade.
Sure. Sure. It's the thinking. It is. It's the process behind the content.
Right, and the thing is that back to that tomb of knowledge, you need to have an ability to operate in a larger sphere processing that knowledge. And there's an interesting piece that, but we'll bring that up later.
Yeah.
But nonetheless, facts are cheap and accessible, and they're becoming more accessible and cheaper and more prolific every day. But if you can't think about them, if you can't
Analyze them, synthesize them,
if you
evaluate
can't
them.
answer questions, if you can't solve problems, it's just, you're just another guy punching a keyboard.
Can I make a plug for the standards of practice?
Absolutely. We've talked about those, Nancy. Go ahead.
Mathematics
Yes.
practice and the new generation science practice.
Absolutely. They're built in to the new frameworks.
They're built in and we just don't realize the importance of them.
You're right.
We're just looking at 3 pages in the Massachusetts framework
Yep.
and saying, here we go again.
Couldn't agree with you more.
Not deliberate in our incorporation of those, then we're back to the
Yeah.
same type of.
You're right. So they knew, the designers of the standards knew that we should have practices in science. And guess what? We should have them in math, and we know that they're in writing. And in reading, there's a process that we follow to get for kids to learn how to read. I mean, it's so out there that it's important. But I think you're right. People flip through the practices like, I just got to get to the content. And if we teach the practices, the content will come that much easier. Couldn't agree with you more.
Just one quick thing I'd say is that, kind of example that comes to mind. I learned to swim very late. I learned like 2 years ago how to swim. And and it's funny. Thank you very much. It will shock you even more that I actually really like the water and sail and do things like this and couldn't swim. Kind of frightening, actually. And so I was getting ready for this trip, and I had to learn to swim because they were going to throw me in a pool with all my clothes on. I had to get into a life raft, do all these sort of things. So I go and take my swimming lessons. And I learned to swim. Realize that there's processes of breathing, of certain strokes. And when you screw that up, you're in trouble. And that's the thing. The practice, the process of swimming involves the practice of proper breathing, of proper motion and strokes and head position and body position and all these sort of things and coordination. Who would ever, I think about instructors like, who would instruct an Olympian, an Olympic swimmer, and say, you know what, the practice of breathing, the hell with that. We're here to swim. Today we're going to swim. Breathe on your own time. And the guy who figures out how to breathe is the guy that makes it. And that's, when it comes to these math, ELA practices, the STEM practices, that's what we're talking about here. We're talking about getting off the dock, getting away from the sort of like what we have to do sort of thing, the old school, bringing it forward and then processing, the tools for processing so that we can be really efficient and go the distance. So that's where this comes in, UBD.
Yeah.
Is this you or me?
Understanding by design. How many of you, just show of hands, are somewhat familiar? Yeah, we figured they would be very good familiarity, so we won't spend a ton of time on this, and we can't because we're running out of time, so it kind of works out well. Understanding by design, Wiggins and McTighe are the two who developed this, and it's really that whole backwards by design model. It's designing lessons with the end in mind is really their whole focus. And the 6 facets of understanding that they talk about in their work provide a conceptual lens through which teachers can better assess student understanding. And these 6 facets of understanding are explain, apply, interpret, shift perspective, empathize, self-assess. What do they remind you of? Bloom, higher order, right? Getting kids to think and understand in a different way. We always seem to come back to the work of Mr. Bloom. And so, you don't need to demonstrate, kids don't need to demonstrate every one of these understandings for every single subject area. You may not empathize in math, but you may empathize in social studies and take a different perspective and understand how certain people reacted to certain conditions and how would they have reacted and so on and so forth. So these 6 facets of understanding that he's identified help teachers better assess student understanding. So
one quick thing I'd say.
Yeah, go right ahead.
Just, kind of that element of empathizing in math. Well, I understand that, that this is understanding sort of the depth of the way a student understands the content and what we're working with. If a student can take something like math, the example of the $500 Rosetta Stone, and can use that to empathize.
Yeah, well, that's a good point. That's a great point,
I think
Francis.
that's really what we're going for.
Great point.
I think traditionally, though, that you're exactly right.
Yeah,
and actually, there's a document in your packet that will tell you exactly that. And it's funny that they don't actually address science, because science is sort of one of those like slippery pig kind of things, right? But I think that all of these, at least in STEM, are certainly an element. So I would just challenge you in like decompartmentalizing.
Excellent
That's
point.
a part of it.
Excellent point. So there's 3 stages that they've developed, and as Francis talked about, and I'll just have you take this out now so you can see. Go in your green bag and pull out the little packet. It says Understanding by Design. Just so you kind of have that in front of you. So the 3 stages, you identify desired results. What are the standards? What are the practices? What are the processes? This is starting with the end in mind. Where do you want to end up? And where you want to end up will dictate how you get there. Anyone add?
Yeah, so standards, state level, right? What are you required to teach? Practices are also part of the standards, and as the standards change, they're going to become more part of the standards. But the practices are not only the standards. That's the thing. They extend beyond that. And so that's when you look through the NRC practices that we've given you. That's what we're talking about here. The processes now are that science or engineering. Okay? And it may, and again, if you're applying this in ELA, it might also involve more than one process. It might be the scientific process also involving the writing process. Okay? So this is sort of laying your groundwork. Stage 2.
Go ahead.
Determine the assessment. So what evidence? So now you have to ask yourself, so we just talked about what you're going to accomplish, right? Practice, process, standards. That's what we need to accomplish. So what's the acceptable performance level? What is success, right? All the time we hear things like low bar in education. What is that? Well, it's real. Boil it down. It means that when the criteria for success is not necessarily something that's higher order thinking, right? It's not really. So if in the case of the practices, processes, standards, if the acceptable performance level for success is circling something, you got to think about that. Is that circling the moon going around the Earth, demonstrating? How is that demonstrating an understanding of the process? How is that demonstrating the practices? How is that demonstrating the standard? Okay, and is that the only? I mean, there may be an activity like that, and I know some folks are more K1, 2. remove you from the situation. But if a student is at 5th grade and that's what's going on, you have to ask yourself, is that acceptable? So next piece, how will the student demonstrate what they know? So that's where we come into that kind of, is it circling? If you're going to try and demonstrate knowledge of a process or knowledge of a practice by circling something, you've missed it. Okay, you can access whether a student knows the difference between two things. Okay, but that's really not a practice. That's not a process. That's something else. How can you continually evaluate this demonstration accurately? So, what about this is repeatable? Okay, so if you kind of think about this, so acceptance performance. What is the acceptable performance level? That's your expectation. Okay, that's your expectation for the practice and the process. What is a hypothesis? What is a question? What is research? What is acceptable for each of these things? When it comes to collecting data and applying it, what is acceptable for that? How will the student demonstrate it, okay, in your assessment? Are you going to ask them, are strawberries fruit? Because the seeds are on the outside, kind of thing. If you've talked about the strawberries, and now it's just a situation of recalling that fact, what's the value of that? Okay? If you could show them a different fruit, or if you can show them a plant and say something about the fruit on it, or have them say something about the fruit and determine whether it's a vegetable or not, that's bringing it to a bit of a higher level. And how can you continually evaluate this? If your focused evaluation is just on the content, then what you're doing is you're trying to evaluate that tomb of knowledge, right? What you really want to be evaluating is the skill. So can the student take the skill and map it to a new context, right? Can they, because that's the thing, is that now, especially with all the new assessments coming out, you're going to be assessed in ELA through science. You're going to be assessed in math through ELA and science. I mean, that's where this is going. So one way or another, this is going to serve your needs, but you can do it for yourself and get much higher levels of learning even in science.
That word skill in mathematics has an indication of fluency sometimes. So I worry about, I know what you mean by skill, but I worry about using that word. Could a better word be application? Or is it more?
Well, procedural fluency really comes from process. So process is the procedural fluency. So the skill is, I see what you mean. And it's a slippery slope. But the thing is that it's.
The skill that could be the intent of the word skill might not be the interpretation that the audience finds for that.
Yeah, I mean, I think so the root of this is like a skill being like it's sort of a nuanced practice. And so a nuanced practice can have some procedural elements to it, but content, skill, and practice are different because content is static fact sort of thing. Okay, a skill is, a skill is sort of a, it's like maybe we would say like a content-specific.
But that skill is based upon successful repeated applications of the practice.
Right.
Right. A skilled carpenter is skilled because he has successfully, or she has successfully repeated the practice of hammering and sawing and cutting and all of those things. So
In some way, is it like a system-subsystem problem of how we use language? It's just
Right.
You can have skills that are on a very small level.
Right.
Right? Like, I know for the carpenter, I know how to determine whether the top of the table is level or not. I know how to use the level. And it's the skill of how to actually build the whole table.
Right.
Right? And so you have, increasing levels of more
skill, right. Right. You
Yeah,
need
and I think
smaller
a more-
skills to make a bigger skill.
In a more sort of like I use the lawyer example. You know, you can get the content of the law as a lawyer. That doesn't make you a great lawyer. You can be, you know, you can have a very charismatic personality that is a skill. Charisma is a kind of skill. You know, you bring them together, and you can apply them specific to law. Those are practices. So and that's actually how the NRC describes practices. Practices are a combination of skill and content specific to the discipline and are useful for deriving or actually growing the discipline, I guess is a way to think of it. So yeah, it's pretty nuanced, but...
So we're bumping up against lunch, so we have one more slide after this, and then we will break for lunch and head to the afternoon. I just want to say one thing on this slide, and that is what resonated with me when we were putting this slide together is in reading, you know, we have our instructional level and our independent level, right? For those of us that have reading and our generalist teaching. And I thought about that, and I'm like, yeah, that's something that's easy for us to work with. We know where the kids are doing well independently. We know where they need the instructional help. It's the same thing when you assess for process, right? When you assess for the practices which develop the process, what is the instructional level of the student within the scientific method? What's the independent level of the student within the scientific method? Do they need more work on research, experimentation? What can they do on their own? Where do they need instruction? You can almost make that analogy to how reading works in terms of the practices and the process that goes along with it. So then the third and final step.
Okay, so planning, learning experience, and instruction. So once you have sort of what you have to do, that's stage one down, you figured that out. Stage two is how you're going to assess it, the sort of the modes of what the evidence is going to be, that what you want done is got done. How are you actually going to get the students to master this? So what activities? Big piece here is that activities have to combine the standards, practices, and processes of what you're assessing, but it doesn't mean that it's the only thing that's there. If you're assessing measurement, well, if all you're doing is measuring, you're doing it in isolation, that's not particularly helpful. It's actually disconnected, and it's just not helpful. So you have to ask yourself what connects these activities to each other, and the sequence matters. Okay, so you're scaffolding and you're building these up. How will these activities challenge the students independently? Again, if you show them something and then say, okay, I want you to do that thing we talked about. And you show them something and okay, I want you to do that thing you talked about. You might say, well, that's independence, but it's actually kind of prompting. And so you have to be able to back off that. And activities we choose can give students the opportunity, we can back off of it through the activities, or we can try and manage every student and lose our minds, and students won't be challenged, and they'll be the kids, they'll still be that kid on the dock, right? They won't develop the habit of mind. And then the final thing is what materials and prior knowledge do students need to be successful independently? So the very last thing we ask ourselves, because stage 3 is the final stage, the last thing we ask ourselves is, what is the actual stuff that we do? So that's like the final piece. It's not well, we have the rocks and mineral box. What do we do with this stuff? How do we make this? I know that seems like it's a reality, if that's what you've got to work with, but you really have to start much earlier on. And if you know that's what you have to work with, you have to think about maybe that's creating a bit of a box for you, but it shouldn't define the rest of the process. And that's that germination point for communication about what you do need, right? It's a long-term process, but if you're not articulating a need even for permission to teach something, then how does the administrative structure work and vice versa? So that, so very quickly, that's the kind of final stage where it actually gets down to what you do.
So that's sort of the Cliff Note version of that. There's much more depth and detail in that ASCD publication that's in your bag to follow up a little bit more if you're want to learn more about understanding by design, or you knew it and you forgot it and you want to remind yourself, or whatever the case may be. That PDF, or rather that document that's in your bag, it has some really good questions at the end. There's a good FAQ section at the end of that document, which really gets into questions that you probably have as an educator in terms of how does this work and how do the pieces fit.
We're going to kick off this roundtable discussion. So what we're going to do, the format here is going to be questions starting from Scott and a bit from myself, and then we're going to take questions from you all, as well as from other people who are on the panel. And the idea is that we want a discussion where we can learn from each other and learn from each other's perspectives. So I'd like to introduce the panel members, roundtable panel, starting, I guess we can go left to right. Folks' titles, unfortunately, are not on the slide just because they don't fit. But I will try to read them off of the cards and blame your email signatures or the website at your company if there's some nuance that's missed. So Chris George from Excelis Technologies, Vice President of Manufacturing. And you'll have met perhaps some of these folks on tours. Heather Pothier, who is Global Director, Scale-Up Manufacturing Programs at Abiomed. Shannon Russell, who is Patient Advocacy and Corporate Relations Specialist also at Abiomed. Pam Bowden, who is the Superintendent of Schools for Manchester Essex Regional. Morgan Evans, who is Staff Scientist at Applied Materials, also known as, or formerly known as, Varian. Priscilla Nelson, who is the Associate Professor of Education, but technically Chair of Elementary and Special Education here at Gordon College. And John O'Connor, who is Chief Technology Officer and Vice President of Engineering Technology, is that correct? At Analogic. So really, thank you all for coming and being a part of things here today. So to kick it off, I'm going to throw it to Scott to kind of get things started, and maybe, I don't know if you want to give people a second to
Yeah, I think even before necessarily we get into a question, I think it's important for the folks on the panel to understand this morning, this is our fourth session of STEMsquared, and STEMsquared is strengthening the teaching of elementary minds in science, technology, engineering, and math. And so the folks who are before you are mostly elementary educators, administrators, outside school time people, but with the focus really on the elementary level. And the reason for this whole series and the reason for you folks being here is that a lot of the attention around STEM instruction at the state level is always at the middle school, high school. And I think really our contention has been that we really need to start talking with our kids about this early on, in the early years, and develop the practices and processes that kids need to follow in that certain way of thinking that goes along with being a scientist or an engineer, and developing that and using that in all the different subject areas of school. And what I think is very, very important for the panel to know is this morning when we did the debrief, a large part of that conversation was a great appreciation on behalf of everybody who is looking at you right now, and the fact that the level of care and effort that you put into those site visits, I can't tell you to a person, we were all sort of talking about this, everybody was so impressed with, it wasn't like, hey, they just rolled out one person and some milk and cookies and said, this is great, we'll have, some teachers in and we'll run through this thing and, it'll be nice to do. It was way more than a nice to do. Your efforts that you extended to the elementary educators here and to the whole STEMsquared organization is greatly, very much appreciated because everybody was just so overwhelmed by, 8, 10 people putting on a presentation and taking them through the departments and the rooms and really having an in-depth conversation about what it means. So I think you guys would agree with me on behalf of everybody sitting here. I think you see heads nodding. Thank you to all of you guys. Because it's very, very important. And I think that leads nicely sort of into the first question. Chris, I'll just start with you and we'll probably just go right down the line on this one. And know that, and this is an easy one, I won't ask any square roots or anything like that. Know that any interplay on the board is great. So if like Pam has a thought that ties in with what Chris said, feel free to kind of jump in. And if you guys have questions, it's really just an opportunity to kind of bring the field trip here, so to speak. And we'll go right down the line on this. But the first question is sort of, in your role, right, as Director of Manufacturing at Excelis, what is your interest in being part of all this? Why did you say, this is important, that I want to show up here on a Tuesday and come and talk and have folks come up to Excelis and see what we do there and really help these teachers learn more about STEM. So what is your interest? Why do you think this is important?
Well, Scott, first of all, thanks for everyone coming here through this brave, cold day. I believe it's important because of the amount of hiring we do, the technology and the interaction we have with so many disciplines. It was some of the things that came out during those plant tours were how technicians on the floor, some just graduating from high school in a technical, maybe a technical role, transpired and work with physicists, mechanical engineers, mechanical designers, electrical engineers, with multiple levels, multiple degrees. So it's so important that they have that foundation, both in communication, being able to communicate, being able to have a desire to learn more about math, learn more about science on the elementary school level. It's extremely important. And I've seen it through the many times we've hosted Take Your Child to Work days, where we've set up little events and little science projects for the kids to participate in, and how much they enjoyed showing their parents what they could do. And then later on, they came, we've been doing it so many years, you'd come back and they're applying for high school scholarships and things like that. So it does make a big effect.
Yeah,
and you could see it on the parents' face. You can also see it on their face. It doesn't necessarily, I've been there for 14 years. I've seen some of them come through, but not very many. But I'm sure that a lot of them have gone into technical degrees as a result.
That's great. Thank you. Heather.
Welcome, everybody, or hello, everybody. I haven't done this panel thing before, so.
We'll guide you through.
For me, I think a big part of why I enjoy doing this and having the STEM team come through is because it helps promote math and science. Doesn't have to be a scary thing, and you can do a lot of really good things with math and science. I hear too many children talk about, oh, maybe I don't like that class, or I don't really know what you do with it. And so this gives us an opportunity to bring educators in that can take back to the classrooms and talk about what you can really do with math and science and the types of careers you could have in the future. It's also very important for us as a country to make sure we're developing those skills here so that we can continue to grow and be very marketable and have a lot of strong businesses here within the U.S. And it's very important to get that education early so people have the interest and students have the interest and will then look towards going to the engineering schools or the technical degrees and stay and help grow our businesses here in the U.S. and make us a very strong economy. So.
Good. Thank you. Very good. Shannon?
I think I'll just add a little bit of a soft addition to that is I think this program is great because it's mutually beneficial. It's, it creates inspiration. I think after our employees that were involved in the tours and after you all left, they're sparkling. They're so inspired to go back to their desk or back to wherever they're working and just do the best they can do because it brought out what brought them to become what they are. And I think that's so important to create for children and give them that inspiration.
That's great.
I guess as through the educator lens, I have multiple layers of interest in this. I think, my initial introduction to the STEM pipeline work was certainly it was on that high school level, and it was to help identify students who would be possible college candidates and then candidates for the world of STEM work. I think as an educator, particularly at the elementary level, going into it, you always look at education for citizen preparedness, and I think having a basic foundation in the sciences is going to be necessary just to function as a good citizen in this country, to understand that which is being put before you in any election. You're going to have a basic knowledge of environmental science, nutritional science, to navigate the world of what you are putting in your mouth or what is being put before you as choices for your food sources, in addition to perhaps grabbing the interest of students who might be able to forge a career out of these pathways. So I think it's really becoming as basic as English and history to create good citizens who can participate in the democracy.
Great. Thank you. Morgan?
Yes, just confirm your question. Your question is really about why elementary students rather than high school, middle school students.
Yeah, I think certainly more along the lines of the interest of Morgan Evans in applied materials and helping this cause of elementary educators learning more about science, technology, engineering, math. What do you see the value and the importance in?
Yeah, so I can build off Heather's or other comments about civic mindedness. Certainly it's the right thing to do. But at a more guttural level, it's just fun. Someone said that young kids decide by middle school if they're going to be technologists or not. And I see that from my own experience and from my son's experience. And what I also see is that a few teachers definitely you've probably heard this 100 times, but made such a big difference in my life and my son's life. I remember an 8th grade English teacher that just taught to every level, to every kid's level in the class. And my son came home, and it turned him into a reader, where he was more of a technologist, and that was fantastic. And so my reasons are both selfish and selfless. Selfless meaning the civic mindedness, but selfish because it's fun. And it's a rare chance to, with all due respect, leverage your efforts to attack the attitude. Probably most of my answers today are going to be about attitude rather than skill set. It's an old axiom to hire for attitude, and you can teach the skills. And so it's a chance to, right from the get-go, I didn't know if I was going to be a technologist, but I knew I wasn't going to be a doctor or a lawyer at that age. And so to give the kids some confidence that they can do what they may want to do, even if they're not that bookish. It's really the attitude that matters. And so you guys can give them the confidence, and you can, so many more teachers here than I can ever do, build the confidence in our local students, whereas there's all this talk about the academics of other countries and whatnot. And that comes later. What has to come first is a desire to, maybe at lunch or after school, ask extra questions. If it's not your parents, it may be a teacher, it could be a coach, whatever, and to really pique people's interests. And that's where I find fun.
And I think we find, and we've had this conversation in this room, that confidence to the kids, it's also giving confidence to the teachers, right? Because, you go through a lot. I remember I went through my training as an educator, and there wasn't a lot of time spent on science, when I was back 20 years ago. And I think, Priscilla might talk a little bit about this now. The teacher prep programs that are coming out are giving the teachers more confidence to attack some of these things and be able to confidently address science, technology, engineering, and math, and the process and the practice skills that go along with it at the elementary level. So, points well made.
I just want to build off that a little more. So there's the high-tech opportunities, the technical opportunities are mainly in the U.S. It's just amazing that we don't, it seems to me from my limited experience, necessarily prepare the kids to be hired in the same proportion as the opportunities that are here. And I bet you most parents don't realize what high-tech companies are on 128, or even that what Route 128 was the first high-tech mecca. And so I go on and on, but I'll pass this on.
Yeah, and I'll just add one more thing to that. Who's our Analogic folks? John. I drive by Analogic every single day on my way to work, and I didn't really notice it until I actually went there to visit. You know what I mean? I was like, oh my God, this place is amazing. And I drive by there every single day going to work, and I saw the sign on 128. So you're right, it's all around us, but it's exposure, and guess what this is? Exposure. Priscilla.
My interest is in teacher preparation, and there's a lot of bad press out there these days about how teachers are prepared. There's a lot of criticism. And so one of my passions is that we be preparing teachers who are well prepared. And in order to do that, we need to keep up with what is current, what is new. And this whole idea of STEM, it was not part of my teacher preparation. And it's actually relatively new among what's happening in the Department of Elementary and Secondary Ed. And so we are very much embracing it and want to make sure that the students who leave our institution and are coming into your classrooms to do their student teaching have been prepared. I'm very interested at some point, not right now, but at some point hearing from you, what would a well-prepared student teacher look like to you, particularly in this area of STEM? And it's something that's under construction here. We're working on it right now, and we continue. But we do not want to have you having to repair teachers who come to you. We want them to be well prepared.
Thank you.
Thank you. Thank you for having me today. Just a couple things I'll add to the notes. Chris made the comment about bringing people in out of high school. At Analogic, we actually have kids in our CAD group in high school. We bring them as interns, as freshmen in high school, and want to have them grow. And a lot of them have worked in the robotics competition, that's First Robotics. And the Peabody group actually has done extraordinarily well in that. And so selfishly for Analogic as a company, and we're about 1,000 people in Peabody right now, we're looking to bring in the best people we can get. And the way you do that is to grow the people starting young. And as important as STEM is, I came from a Jesuit institution for college. And one of the things that you taught as one of those schools is cura personalis, which is development of the whole person. And as important as STEM is, it's the entire growth of the young people that we have to have, not just in engineering, not just in science, not just in mathematics, but across the board. Because one of the things that we do, and we try to do, and I think Morgan kind of mentioned a little bit of this, is we want the best people, and not necessarily who has the most skills up front, but you need people who can think. And one of the things I think that you folks have the greatest capability to do is to spur three things. And I was thinking about this yesterday. Scott sent us a couple of questions ahead of time. The first thing is curiosity. Making the young boys and girls interested in what they can do and how the world works and why the world works the way it does. And that's not just in engineering, but across the board. And the second is perseverance. Going through obstacles and making sure that you're trying to get the job done. You don't always make it, but you are put it in their minds that I can do this. I can push through what I need to push through across the board in whatever field they go into. And the last is finding something that they love. That's fundamental. You have to find joy in what you do. Otherwise, it's a job. And if it's a job, it's not fun. It comes across as a job and not a career and not something you want to do. I was really lucky when I got to college. And I really didn't find out what I really wanted to do until I got to college. I had a professor in school who was fabulous in physics. And so I fell in love with physics. And that's what I went through for my degrees. And so now I've been really lucky over the last 30 years to be able to work with that and to make a difference, I think, in the way that our products are designed, our products are developed, and the way our people work, and the way we bring new people on board. As an example, I made the comment about we want the best people. We want people who can think. And that was the same comment about cura personalis. If you have someone who can think, you can teach them to do what you need them to do. When we interview potential employees at Analogic, we take them on a tour of the factory, and I know a number of you have seen the factory, about 500,000 square feet in Peabody. And when you walk around our factory, we have 2 courtyards. And in one of the courtyards, we have a large glacial rock. And everyone who goes by asks about it because, it's just sitting there in the middle, and it's about maybe 40 feet long and 20 feet wide and 30 feet deep. And so they're all kind of staring at it when we're walking through one of the corridors, and I like to ask them about it. And when they stop, especially the engineers, I'll say to them, "Oh, what do you think of that?" And they say, "Where do you think it came from?" And I'll ask them, and then I say, how much does it weigh? And I'll just step away for a second. And I don't really care if they get the right answer. But if they can think on their feet and say, look, roughly it's this size, it roughly has this density, that means if I can multiply in my head, I come out with this number. And some people panic, and some people get literally the right answer. I had the most amazing person gave me the right answer in about 8 or 9 seconds. It was astounding. And,
Job offer on the spot, I would imagine.
Sorry?
Job offer right on the spot, right?
Actually, no, he didn't fit for the position. He was actually overqualified.
Okay.
And so, but that's really what I think drove me to help work with this group. And I've also worked at other levels. I was at Northeastern in November, where they were looking at high school applications for STEM. And out at Northwestern in December, where they were looking at college level for STEM. And so it's kind of a continuum of needs to ensure that we have the technology-driven capabilities for our economy. Thank you.
Go ahead.
Can I toss
go right
a
ahead.
question to the panel? I'm sure many of you out there are thinking, this is what we would love to be doing, which is instilling curiosity, teaching perseverance, getting back to some of the roots of what we did. I'd be interested from the panel, particularly people in industry. I think in education, we're getting a lot of push in different directions. And the most common direction coming from all industries is rank and sort your students according to standardized testing and test more and compete internationally on those exams, which is completely counter to what everyone keeps telling us they want in a well-prepared person for the job force. So can you help us make some sense of that?
Okay, I'll start this time. When we say we need the best people, that's around the board, around the entire area. When you go look at the kids coming out of high schools or going to college, the competitiveness of the U.S. academic world now is extraordinarily high. And a lot of that is because international students are literally flooding the market here. When I went to graduate school, I had 20 individuals in my incoming physics graduate school class down at Yale. Only 6 of them were Americans. That was 1979. It's actually worse now. And so one of the things we have to be able to do is to drive additional, additional capabilities. And like it or not, one of the things that makes a difference on whether you get into a high-level university or a high-level college or a high-level graduate school are what your test scores actually are. So it's actually, you need across-the-board capabilities. So you don't want to focus, in my opinion, you don't want to focus 100% on testing. And I know a lot of the testing in the Massachusetts schools are very rigid in the 4th, 10th, and set of grades. And they are critical because you need to know where people stand. And not so much that you rank the kids, but it's, in my opinion, it enables you to know who needs additional assistance to push them up, to give them the capabilities either to move ahead if they want to or go to a community college or to a university, to give us the capability for the people that we need for hiring.
The assessments that you referenced don't do that, though. The assessment battery that exists now doesn't do the formative work that you'd like to do. And it's not for an argument. I just think it's something that I know schools is wrestling with. It's the time and effort that goes into producing that which gives you an external number to show that you are high quality, draws down so much time from the classroom environment where you would otherwise be promoting creativity and investigation, that unless we lengthen the day and the year, which I don't know that studies show really achieves what we would want to achieve, especially if you look comparatively at Europe, we're kind of at a crossroads, maybe a crisis point in terms of seeking the identity of what our schools should be. Because I think we're investing lots of time and energy in something that's been shown to not be productive internationally.
I might be able to address some of that, both in my position and as a father of a 15-year-old in Pam's school district. I see the numbers as a ticket to the dance. You need a good number, as John said, to get into the right school. And because the world's so international, I feel for the admissions people. I mean, how do you compare someone from Singapore to Cologne, Germany, to South Africa, or whatever? And like John, I went to school for physics and PhD, and it was 1 in 30, me. And so what the test numbers do show sometimes is the passion. Are they willing to put in the effort to get at least an adequate score? Pick a number on the SAT, 2,000 or whatever. You've got to have enough credentials to get into the school and into the business. But once you're into the interview, either case, in the admissions process, it is up to the hiring person, the admitting person, to do as much as John did, to say, oh, they're overqualified for this position. Maybe we have this other position for you. Or maybe, in my case, the admissions counselor at RPI said, well, you're not really an engineering fit, but you're a physics fit. We're going to offer you this, even though I had applied for engineering. I said, okay, and that was very much guidance to my life. So I don't think we can get away from the tests, but the best teachers, from my son's experience, never talked about the MCAS. The 8th grade English teacher never mentioned it. There was never a prep day. My son never came home and talked about it. And as far as I could tell, she prepped the kids much better than any other teacher who did talk about it. And I can only assume that the teachers that were talking about it were nervous for themselves, nervous for their kids. And as full disclosure, I was on a school committee in Pam's district. And what I said at the time was, look, the MCAS is for me, a school committee member and a parent and taxpayer, to rate you, the administrator, not for you to rate my kid. I try to get that out there anytime I can. I'll leave it there.
So I want to go touch upon something John brought up. I wanted to give you, I've been giving virtual high fives today, so I wanted to give you a virtual high five. Because I think the people in the audience would have thought I drove in with you and prepped you, because all the things that you said tied into exactly what we were talking about this morning. And one of the major things we talked about this morning was thinking. Kids need to be able to think, right? And we made the point this morning that STEM is just an acronym. That's all it is. Someone just decided to put the first letter of science, technology, engineering, math together and made a nice little word, and it's STEM. And I think we have made STEM this sort of mystical thing that it doesn't have to be. We're trying to debunk that a little bit in the sessions that we have here. And really the glue that holds STEM together is using practices to develop processes to think in that way, to think in a practice and process manner. And the more that we can get kids to think in sort of that, using practices to develop a process and think in that manner, and the more we can extrapolate that off into other subject areas, social studies and English language arts, and we talked about all the connections between the subjects. So I just wanted to say that it tied directly into some of the things we were talking about today. And another point that you brought up is, you said communication, I think, was big, and I think you said these high school kids, when they come in, their personality, right? And developing that personality and getting them to a point where they know how to function, maybe content-wise, but also maybe what some people think are softer skills, right? So I would ask you, if you're sitting in front of a group of elementary educators, so for the high school kids to have this thing that you want them to have, what seeds do these folks need to plant in elementary school in order for them to have this thing up here? What do you think about that?
I actually thought about this a little bit last night, and there are ways where I think with very simple, very inexpensive props, I'll almost call them, that you can show young kids what can happen in the world. I actually, when I was in graduate school, I taught a course at Southern Connecticut State University for incoming freshmen. And it was an introductory physics course, no calculus, and the first thing I wanted to do was to find out why they were there. A lot of them were there because they had to be there. And then I wanted to turn that into they wanted to be there. And so I literally put together very simple, I would call them pseudo-experiments, to show kids the difference between what happens when you shoot a marble from an air gun, the air gun being a little something you pump up, not a true BB rifle, or a golf ball, or a piece of styrofoam, and why they travel different distances, and why one flies across the room and hits the wall, and one only goes about 6 feet. And then we did it with inclined planes and things such as that, just very basic, very simple, and I would have them do it all, not me. I would just set it up and let them go play. And by the end of a couple of weeks, I had like 6 or 7 people who came up and wanted to do it all the time. And so it kind of spurred that group. Granted, they were 18 years old, so it's a little different. But it's very similar to what I think could be done in the elementary regime, where you can put together very simple, either physics, math, or chemistry, or biological experiments that can trigger that same curiosity that the kids can also have in English and history and the arts. Because it has to be across the board, as I said earlier. So that's just some things which I think are available, and I'm not sure, and maybe you can comment more whether they're actually available in the school systems, anything like this, that you folks don't literally have to go to Walmart and buy. And if they're available today, that you can put together small, maybe once every week or something like this, that the kids are going to go, wow, I can see that. Or when I actually was in like 6th grade, I think it was, our teacher did an experiment where we generated hydrogen. And we filled up balloons with hydrogen. And we did a couple things with it. We let a couple go and see how high they went before they popped. And then we literally lit some to see what would happen when you had a flamethrower with a balloon. And so just so that everyone would see the difference, what could occur, and what can actually occur naturally in nature. And it triggered a number of folks in my elementary school. I went to public school all the way through, down in Woburn, and it triggered a whole bunch of us to look at the sciences and engineering.
You said one more word, and Chris, I'll jump to you real quick. You used another word, and I wrote it down. You said resilience. I'll say grit, right? There's some great work. Angela Duckworth is a researcher, and she's out there talking about grit. And there's some great work being done on resiliency and grit. And basically, some of the studies that she's been working on lately is that children with a higher grit factor perform better than children with a higher IQ because they have the resiliency to keep going even after they fail, right? And grit is almost a better determination of future success than IQ, according to some of her research.
I would agree with that.
Yeah. Yep. I have to say yes, Chris. She's my boss. Yes.
No, this won't be long. I would just, and I'll double back on my point and ask you for some help before we all go, which is I know some of the districts represented. I don't think resources in terms of creative opportunities for kids is a huge issue. It is different in every district, but in terms of provisioning a class with some exciting and stimulating experimental objects that we could set up kids to have experiment with, I don't think would be a problem. And I think most of our parent communities, if we ask for things like that, would be there to help out. The resource we are struggling with is time. And it's that time resource that doesn't allow, I love the way you explained your class. You set them up with this activity and then let them go think about it and explore. Where I know every one of you in this room is under the gun and has every minute of the day scheduled, and that exploratory time isn't there because of some of the other pressures coming in. So we need the community of businesses, the STEM sciences, corporate, to be pushing as much on the legislators to help us reorganize the time of the day, what we do with that time, so we can provide opportunities to spur creativity, grit, and innovation in our classrooms.
Yeah. Chris. There you go. Chris. Oh.
Down the other
Heather,
side.
she grabbed the mic from you, Chris. What's going on?
I agree wholeheartedly with the hands-on activities, and I know it's definitely challenging to find the time, because we face the same thing every day at work. We're trying to constantly re-educate our team when we bring in new employees, educate them on some of the manufacturing practices.
Hold that a little bit closer. I don't know if it's on or not. Maybe use the
I
one
think
Morgan's
the
giving.
switch on the bottom, just the mute maybe on.
I didn't mean to interrupt you. I'm sorry.
Is that better?
Yep. There you go.
Okay.
Thank you.
So even in the industry, trying to find that time is absolutely challenging, but critical. And we also do a lot of very simple models and experiments. If anyone comes to my office, I have bins full of Legos in my office for training classes we're doing every month. But it's very important to make that time, because for many students and myself personally, those types of experiments were what got me interested in maths and sciences. Taking a tour of a bubblegum factory when I was in elementary school, that spurred some interest in creativity, doing hands-on activities in the classroom. And nowadays we have a lot of opportunities available. If you look on TV, Mythbusters, watching part of Mythbusters and having the students try and work through those problems. But as far as the time, you probably have to tie it in with your curriculum around MCAS and, okay, how can I turn this thing in to teaching towards the MCAS but not telling the students I'm teaching towards the MCAS. So if you can get creative with that, I highly encourage it. And another big opportunity is anytime somebody tries an experiment and it doesn't work the way they expected, use that as the key learning moment, as I'm sure all of you do. But I find we learn the most from our mistakes versus if we get it right the first time, great. It worked out really well, but we never truly learn as much from that versus going after it, touching upon the grit aspect too.
Absolutely. Great. Chris. This better be profound, Chris. You've had a
No,
mic so long.
I even forgot what
You
I was
know?
going to say. I guess the one thing I hear from all of us on the panel, at least from industry, is make it fun for the kids.
Yeah.
Okay? Listen, we're competing against, and you're competing against, some great, great video games. And they have iPhones and their smartphones. They play stuff that really boggles your mind, but they challenge themselves. They play these games that, and you know them as well as I do. They play against people they've never in different countries. They don't know who they are, and they're challenging them for social studies, or they're challenging them from solving math problems. So your challenge is to go into those classrooms and put together a subject that they're going to want to. They're going to be passionate about trying to get the right answer. And when they don't get the right answer, you celebrate the losses and the victories the same way and help everybody work towards finding the solution toward them. I can see it. Some of those things and some of the largest jumps we have from a manufacturing standpoint come in when we bring the new college hires in, or even the co-op kids, or even the high school kids in, because they bring in new solutions nobody thought about. And, we might think we stay on top of technology. We don't. They're much further ahead than we are, and all we need to do is harness some of those resources. So I don't necessarily, I'm sorry, I don't buy the idea that we don't have enough time to plan this stuff in the classroom. I think it takes us a little, use what we already have in there, what they want to see, and blend in the science, the engineering, the technology that's going to make them really, really be passionate about asking questions and being inquisitive and coming up with projects for themselves. I mean, I've seen some of these things that they've brought in that, race cars with a rubber band. They're doing kinetic energy with it. And they made it out of a Coke can. They had to drink the Coke at lunch or drink the soft drink at home and bring it in and then put the thing together. Or out of toothpicks and marshmallows, creating a three-dimensional drawing. Or using Minecraft, which is another software that all the kids like to play on Xbox, to build three-dimensional drawings and do volume calculations with it. Really, really, really start thinking about some of that stuff. And you'll be surprised how much they'll come in with projects they want to do. And it won't cost much. I don't think it'll cost much at all. And I think from a time standpoint, it's so value-added. I can't say enough about it. Great comments from everyone on the table. I think... just don't let time be the reason why we don't challenge them.
Thanks, Chris. I just wanted to build off your Minecraft comment. I can't say enough about Minecraft. My son plays all sorts of things on there, and he has since a very young kid. He's got his own PC. But it's basically, if you're not familiar with it, 3D Legos on the computer space, right? But it's also got electricity. So first thing he did is build our house down to the closets and the beds and the chairs. It's unbelievable. The three-dimensional thinking he was doing to be able to build the staircase and everything else. But then he went on to build, if you're going to mine something, you got to get trained to get it out. And so he built all these tracks, and it's got switches, and so he's learning about electrical circuits and whatnot. And I recently heard over Christmas, I haven't had a chance to play with it yet, that Google education arm has released quantum mechanic package for Minecraft. So these kids are going to be playing dice with their moves, but it's not going to be regular dice. It's going to be quantum mechanics. I haven't checked it out, but the options are limitless.
One of the unique things about all these programs is the kids play in groups, and they learn from each other. That's one of the, it's not the old days you stand in front of a Pac-Man machine and drop quarters into the thing, right? They're playing in groups. They're teaming up, especially in building villages, building things. The amount of interpersonal skills they build between that, it's unbelievable. When you bring somebody in, it doesn't have to be that person that solved the volume question that was presented to them, but it's the person that works with the group of people to be successful on a project and to work towards a common goal. Goals that might be solving some very, very difficult technology problems, or something as simple as methodizing a production line to be efficient. They're working with people, they're interacting with you, they're interacting with their peers, and they're recognizing where their limits are and where they need to grow. So I think those are opportunities that even if you carve out a small section of time in each of those classes, I think you might be successful.
Well, that's one of the things we had. Go ahead, Francis.
I really love this discussion. And I think you're touching on something, and I'm sure some folks are probably wondering this. We talked a little bit about the hard skills and how we maybe assess those on tests and what those assessments mean for getting into college. What about the soft skills? And I really love that sort of boulder in the courtyard, off-the-cuff sort of assessment of what I would relate to as a hard skill sort of assessment. And I think about somebody who I met who had started a consumer electronics company, and they talked about going to Ivy League schools and recruiting young engineers, and they'd ask them things like, why do boats float? And why do they, and had such a spectrum of answers that were sometimes quite off the mark. So there's a hard skill component of this, but how do you assess the soft skills, especially in that sort of like informal sense? And I see that as a piece in education right now where we say, yeah, the hard skills are important, but do you really want the person who can only calculate this? And it sounds like you don't. So how do you assess that? Anybody, if you have a...
I'd love to jump into that. I tell my son, the STEM stuff's going to get him only so far. The interpersonal is everything in the end. I'll leave it there.
Okay. So they're important, but how do we assess them?
We actually do round-robin discussions, and both individual interviews and team interviews to see how people interact. Chris made the comment of working on a team. When push comes to shove, there are very few, almost zero, inventions that are similar to the story of the apple falling on Newton's head and he discovering gravity. That almost never happens. And the way it really works is there's a necessity that comes out. And necessity doesn't necessarily mean desperation. It means there's a market need for something. It could be a new watch, could be anything. And that generates a process. And I know both at Excelis and at Applied, there's a very similar what's called a phase gate process that we all use. And you develop a requirement specification out of that need. And literally it's what does the market require? And then that's translated into an engineering specification. And then a team, which is not just design engineers, by the way. The way we like to think of it is a wheel. And at the hub of the wheel is someone called the program manager, and they're responsible for getting everything done. They're the conductor, like of an orchestra. And around that wheel are mechanical engineers, electrical engineers, software engineers, physicists, chemists, biologists. But just as importantly, there are quality engineers. There are sourcing personnel, both purchasing and quality engineers who go out to our suppliers. Finance, because if it doesn't make money, it doesn't matter. And to industry, when push comes to shove, that's what's important. And then there's also marketing, because they have to make sure that you're actually doing what you're supposed to. There's that old cartoon, I don't know if you've ever seen it, where there's like 6 panels, and it shows what everybody has designed. And then what the market really wanted was a tire swing with a rope off a branch. And some of them have 2 ropes going to the same tire. Some have 3 branches that are linked together, because the engineers like to design new stuff. And it's not necessarily what the market needs. And so basically the team has to get together and form. And there are issues. The soft issues are really key, because when a team gets together, and I'm sure you've all seen the different stages of teaming, forming, norming, performing, et cetera, and you have to get past where the technological skills are necessary but not sufficient. And that's why Morgan made the comment, I think, that he did, that it's the soft skills make it happen. Unless you can communicate with your fellows and your colleagues, you're not going to get anywhere. We don't hire mushrooms, for sure. We need people who can communicate what they need, what they've done, what it means, which is just as important, and how to get that to the next person in the chain, so that the product, which starts as a concept and an idea of our need, comes out at the back end of the factory and is shipping to our customers, works, does what it's supposed to do, is reliable, is cost competitive, otherwise you don't sell any, and then lasts long enough that the customer is able to use it in the market for a long time. And I think that what we do at Analogic and in my past companies to assess the soft skills is very challenging. But how someone presents themselves is very important. A lot of people, when anybody goes for an interview, they're always nervous. And if somebody is not nervous, that's like a red warning flag for us, because they're either arrogant, I'll use that term, maybe that's too strong, but, and not necessarily a good fit for a team, and that's why Chris made that comment. They have to fit in a team. And everyone's a link in a chain, and so you want to see how they will fit in that group, and that's one of the reasons we do group interviews. We kind of like bounce things around. We have a number of fellows at the corporation, it's the highest technical capability you can be at our corporation. People who did not want to go in the management track at all, but have sufficient and extraordinary, in some cases, technical skills, but they also have communication capabilities. And we'll bring in our interviewees into a room, and we'll have them present to us. That's another way we test our soft skills. If they come out of a graduate school or an undergraduate school, we'll say, pick whatever you want. We don't care what it is. It doesn't even have to do with anything of the job, or it could be, designing why a baseball curves, and which is a really challenging physics problem, by the way, and and present it to us, and we'll just see how they react. how they present. Do they look at people? You know, do they look you in the eye and say, I do this, and this is why I do this. And here's why I think this would be good for us to go do going forward. And then we pepper them with questions, because you want to see how people react. It's a pressure situation, it always is. But you want to see just how people are and how they're going to work with the best, I'd say the strongest technical team in the company. And how, if they can hold their own and stand their ground, and sometimes push back. That's one of the things we want to see. Are people strong enough to push back? And those are the folks that you know can think on their feet, can think and admit when they don't know something. That's just as important, by the way. And be able to learn going forward. And that's kind of the way we test the soft skills at Analogic.
So Shannon, I think you want to weigh in, and then Priscilla, I'd love to hear your thought on sort of the teacher prep and then to Pam. So we'll go Shannon, Priscilla, Pam.
I think in a simple way, it's hard to teach these points. I think a lot of them are natural things within a I think identifying them within a child and nourishing these components is really important. And creating scenarios where they can practice these types of behaviors and practice, honesty, practice communication in a team building, and practice failure, practice taking risks and figuring out that these aren't, always a bad thing. Kind of identifying the fear and kind of, breaking down the barriers of the fear. I think just nourishing this, seeing it in a child and praising them when they practice these types of things.
Good. Thank you. Priscilla, from a teacher prep end of things, what do you see in regard to that?
Well, I'm thinking about in terms of, one of the things we talk about is dispositions in teachers, and I think there are also dispositions in children. And this is really a higher order skill, that we're trying to teach. We do try to do a lot through modeling, but there needs to be a real atmosphere of trust for that to happen. And, as I think about oral language development and the emphasis we're seeing on tests, that's something that's kind of gone aside. And yet we know it's really the basis for any reading skills, and we really need to be doing a lot more of it. But it comes back to time. And what are we going to put our priority on? And do we trust each other to be able to do some of that? And I think there need to be some really frank conversations, candid conversations, on, with all the stakeholders, and what can we agree that we can do to, move forward and try these out. Maybe it will work.
It's funny because when I was first starting in education, I had a wise teacher say to me, stay around long enough, it's all going to come around again. And in our discussion here and in your comments, and I'm thinking about, well, I guess I've been around long enough because it's all coming around again. I can remember back when I had just started teaching, the SCANS report, that was the first Bush administration. It's something that came out of the government in collaboration with industry, and the recommendations were stress on cooperative ability and interpersonal skills. There's a lot of really good work going on. This is probably around 92. And I was very fortunate to work in environments where we created structures to teach the skills and to assess the skills. And, this is something practical for you. I would think early elementary, it's a little tough to start assessing them on their participation and their ability to grade each other on their team effort. But certainly as you get into 4, 5, middle, and high school, it became applicable. And essentially, in 2 different organizations that I worked in, we had courses that were grade level reorgs, where it was a thematic, thought-based approach, and every student's assessment for each quarter or trimester was based on interpersonal skills, reading, speaking, and listening, an assessment by team members. Every unit had a collaborative project in which they had an independent piece that they would have to submit, but they also graded each other on the individual's ability to work in the team. We set those courses up where there were 2 teachers, so there were observers of how students were working with one another, so it's not like we're just letting the teenagers grade each other, but there was an effort and a priority placed on reorganizing to develop environments that stress those skills. taught those skills, remediated when there was conflict around those skills, because there was certainly, you can all imagine, there's conflict among kids if you're assessing one another, and it was a re-education of the parent community, because now how kids act, their interpersonal skills became a component of their content assessment. So moving away from that, they got 100 on all of the hard tests, the hard fact tests, but the student wasn't performing appropriately in team, doesn't participate in class, doesn't offer an opinion, became as important as whether or not they read the book and got all of the questions right. So it is time for a frank conversation about what do we really want out of our classrooms. I certainly agree. There is a place for hard assessment. It's necessary to know whether the kids have the content ability. But how we organize our schools depends on where the priorities are being placed and where the accountability components at the state and federal level are being placed, and they will respond to industry, because that's how we got to where we are right now.
Right. So I have a couple more questions I want to certainly venture into, but I want to, for the moment, check in with anybody and see if anyone has a question from the audience that they would like to ask the panel.
I'd just like to know from the panel, what does the panel believe needs to be done with problem solving, communication, and teamwork skills when developing new products? I think that's one of the number one fall downs, in teams in industry. But how can we teach those skills at elementary and other grades?
Problem solving, teamwork, communication, maybe a couple people could address that. How could we maybe start to plant some of the seeds of that at the elementary level?
Nope, the little button at the bottom.
Okay. In the classroom, one of the things I'd recommend is you form teams and you try and build it into the education and the curriculum. I know it's probably very challenging to find the time. There's a group out there called Destination Imagination. It's, for some schools, it's an after-school program. Some schools involve it right in their curriculum. But both my children have gone through that, and that's all really about problem solving. So if you can't think of ideas on your own, I recommend maybe going to the Destination Imagination website. And I don't work for them, so I'm not plugging. But for me, it's a reference of a great place that has problems out there that you can use, and they create not only problems that take time that students might have to come back over several days to work on, but they also have things called instant challenges. So there's something that only take 15 minutes. You introduce the problem with a small group of students, maybe 5 or 6, and you break them up. You give them, maybe it's a couple supplies they have to use. They have a minute or two to identify and brainstorm how they're going to solve the problem. And then they have just a few minutes to execute it. And it can make it really fun. And if there's a way to tie in some of those instant challenges into your curriculum as well, I think you'd really get a lot of benefit. Especially if it's coming towards those times where it's school breaks coming up. It's hard to keep the kids' minds on it. If you can throw an instant challenge out to them, it only takes a few minutes of your class time. Yet it directly gets to, okay, we've got a problem. We need to quickly identify a solution, brainstorm, ties in the teamwork. And if you watch the dynamics of the kids and then analyze it with the students afterwards and talk about, hey, I noticed somebody was really quiet or nobody reached out and asked their ideas, that's also a good educational moment to talk about those communication skills and bonding skills that are really important in the industry as well.
I just want to go right down the line here. Just a 2-word answer, no explanation. So I'm going to kind of put you on the spot here. From where you sit in your role that you sit in, right, in whether it's industry or higher ed or private industry or public ed or whatever the case may be, what do you think is a more important skill? Problem identification or problem solving? Problem identification or problem solving? Just 2 words. Just pick one. What do you think is more important?
Not fair.
Okay.
Problem identification.
Okay.
I agree. Problem identification.
Okay.
I don't know that you can do one without the other.
Okay.
Identification.
Need both.
Of the 2, identification.
Okay, interesting. And what's interesting is I looked at a study yesterday. Francis and I were both looking at this study, and they asked the same question of public ed and industry, And I think public ed, the focus was more problem solving, and in industry it was problem identification from that study that we read. And we certainly had some folks who felt like it was unfair in industry and unfair in public ed to pick one or the other. But that's an interesting read. Thank you for that. Any other questions from out here? We have to use this only because it won't get picked up if we don't. Thank you.
I know you said they could only say problem solving or problem identification.
You get to pick. Go ahead.
I want to know why, because my thought is everybody knows what the problem is. What's the solution is more important. So they all seem to be on the same page, so I want to understand.
Okay.
Yeah, what's the
You
difference?
now get to say why.
I'll start. Contrary to what you just said, most people do not know what the problem is. When you're doing, for instance, in product development, a lot of the problems are very subtle. The ones that hit you like a club, those are easy, at least to know what they are, maybe not to fix. But until you determine what the problem is, how well you solve it's irrelevant, because you're solving something which may have nothing to do with the problem. So in my opinion, you have to identify what the key elements of the problem are. And problems are multifaceted. They're not typically, the switch is off, which is like we just hit a couple of times. Most of the time, they're things that have multiple inputs from multiple disciplines, not just in engineering, that cause the problem to be very significant. And to solve those problems, first you have to find out what the problem is. You have to dissect the problem into manageable pieces that you can then assign to engineers and sourcing and quality folks to address those individual pieces. Then as a team, you solve the overall major problem. And that's why I think from most of the industrial side, you heard identification is the key, because most of the time you really don't know what the problem is. You think you know what the problem is, but a lot of times the problem you think it is not the problem what it really is.
Classroom teachers, I'm thinking about this when we are managing our children who are not getting along. Do we not have to identify the problem and get a solution, among children who aren't getting along? So I think it works that way.
So from what I want from an educator for my son is more the solving. But to build off what John said, the problems we're solving, the valuable problems, are the ones where we don't know the solution, the identity, or the problem statement. What I'm doing today when I go back, where I just came from, is basically disproving the previous ideas so I can then go on to prove and solve the problem. And it'll take us a week or two to take everyone's ideas what the problem is, sort through them, communicate why each one is not valid and not upset that person at the same time. Because there's a lot of arrogance among physicists, as you might imagine. And then we can move on as a team. And the solving, I don't know how to solve most things, that I'm asked to solve. So that process is really walking around to the experts. And I got to go find out who has that knowledge. And chances are it's been solved before. And I just got to put the pieces together.
Pam, before you go, I just want to say one thing. Morgan just made me think of it. From a soft skill perspective, too, think about life, right? When you're in a complicated situation or it's an emotional situation or whatever, if you don't identify the problem, you can't really come up with a solution. So you might be working on some solution and you say to someone in your life, you seem upset. Why? Oh, I'm not upset. Okay, well, they're clearly upset about something. But if you don't identify the why, you might be buying flowers when really it was dinner that you needed to make. You know what I mean? So identifying the problem is important so you can come up with a solution. Pam.
I think that's why my answer was you can't really do one without the other. I kind of go back to my broader perspective at the beginning, which is more societal. I think we're in a society where we're very good at identifying, maybe misidentifying at times, but picking out what the problems are. But we're not good at taking that second step of being collaborative and using all of the skills we've identified today to come up with solutions that benefit the whole. So whether it's Congress or your classroom, it's great to identify what's not working with that school, that classroom, that student, but having it be your second nature to want to resolve that issue and use all of the resources available to you to do it, I think is a critical thing we want our teachers and our kids to be able to do.
Shannon.
I think the innovative mind is always looking for something, looking for the challenge that they can meet and how to make a situation better. You can think you're the best student or best employee when you're meeting your needs or you're meeting your goals. But the way of looking at it is, how can I be even better? What is there around that I need to change that can make life better?
Great. Heather?
And to get to your question, the reason I answered problem identification very quickly is I've seen too many times where you focus on a symptom and you try and jump to, okay, I know how to fix that, but that's not really what caused the problem in the first place. So you really have to get to identifying what the true issue is. And a lot of times that discovery process you go through of identifying things, looking at the data, the solution's very easy. Not every time, but many cases, once you really go through that in-depth analysis of identifying what's truly the problem.
Yeah, I have to say, you said that perfectly. The fact that they have to go through the effort to trial and error, taking the hypotheses of what the problem might be and then trying a solution that might be easy, is very, very valuable to the whole learning process. That's how they grow up their resistance. Or what did we talk about? Grit earlier is the fact that they have to go through that process and realize many, many people say they know what the problem is, right? Sometimes it's an individual thing. Any one of us can identify a problem, but it needs a team to solve it. So you need one with the other, and you need that process of learning, of trying and erroring, and guessing what the problem was, or taking a good educated guess, and then trying something in order to move forward. So you said it perfect. Great comments. Great comments.
I had a couple questions. Yeah. Sorry, I'm not sure what that noise is, but it's not.
So do we know what that is by any chance?
Just some test while the kids are away.
Yeah, probably that. I'll go check.
One of the things that I was on a tour of Analogic as well as Abiomed, and there it goes, right? One of the things that really impressed me was the concept of the Kaizen events, which I'm sure you're all familiar with across the board. But, so I'm not sure what sort of brand of manufacturing process that comes from, but the idea was, and maybe you can help me fill in the gaps, teams identifying issues that they see within their group that they can help solve for the organization, and identifying those and then sort of discussing them and then trying to get that implemented as an improvement. And what I'm hearing here is it's really interesting, because I think about what you're saying in terms of maybe focusing on a feature or focusing on a symptom and developing something that may not actually be solving a problem. It may be just sort of contributing to something that's been created. And I think that sort of approach of the Kaizen events, you're really kind of going to people who understand the problem or maybe see problems that aren't seen by others and trying to elevate those. And I see that happen an awful lot in education. And I think some of the dialogue that was earlier was around, maybe Pam or Priscilla mentioned this, the dialogue with legislators and others about what the needs are. What I see happening is a lot of times legislators and people high up will say, well, what we're hearing from industry is that kids need more skills building. And so what we need to do is everybody needs to do robotics. Everybody needs to be doing this. Everybody needs to be doing that. And it may be addressing a symptom of something greater, but the reality is that there's nobody out there doing the kind of problem identification you're talking about. There's people that are taking a concept and sort of moving it through a narrative, and then people at the ground level, and maybe Pam can talk to whether this is an accurate observation, but people at the ground level trying to act on that information as it's kind of making its way through. So it seems like maybe within the system there's a problem identification issue. How could we learn a bit from what you're doing within education to maybe have some Kaizen events of our own, identify problems maybe more completely and be solving real problems instead of maybe the symptoms? Chris.
Well, Francis, one of the important parts of it is they're process owners. They're not really.
What does that mean to be a process owner?
The problems that they're trying to solve are things that they face every day. And you break it down to things that they can accomplish I mean, we do this with, with a Kaizen event. Something they can accomplish within the time frames that you're going to give them, right? Something that's, the complexity is reduced or increased to fill that void, and they implement whatever their changes are to see if they work. That's the true concept. And not all Kaizen events are successful. But what they do is bring together people from multiple disciplines with everyone has a different agenda because they all have a different function in that organization, but they all recognize what are the value-added things that they want to correct. And they try to eliminate the things that are problems and things they can't solve. They put them in a parking lot. Not that they're going to solve them during that day, but they said, well, the goal is to solve this problem. We have all these other ones. We're going to put those aside. So part of lean manufacturing is to focus on that, focus on the value-added steps. That's how they're successful, is the fact that you're bringing people that are the most knowledgeable. Kids are the most knowledgeable of what they don't know. They're going to come back and tell you, I know my friends don't understand, can do this a lot better than I can. They're going to come forward and say some of those things. So those are some of the things that you can bring back to the classroom and say, oh, okay. All right, so when I think about that work group, maybe I don't put all the best kids in one group. Maybe I split them up. Maybe I put kids with different backgrounds, or kids that don't necessarily work well together, bring them in and challenge them. Not all of them in one spot, but it'll help both of them to build the soft skills.
Sure. As it's making around, a couple other folks want to comment on this. I guess in the case of education, would teachers be the process owners? Would they be the only ones? Would they be the only member of this team? I don't know, as your comment.
Yeah, I think it depends on what your issue is and what you're trying to solve, because at one point you started with legislators hearing things from the industry, but may not have solved the right problem, may have solved the symptom. When you were talking about that, I was thinking, well, a tool or technique that we might use in the industry is something called voice of the customer, where you go out and you survey more people than just hearsay from one or two people, and you have a very systematic way to gather that information so you understand what you're trying to solve. Obviously, that's probably a little more challenging in the classroom to do something like that. But in the classroom setting, I think I'd focus more on, like you were mentioning, the Kaizen, break the problem down so it's in a manageable chunk. You're not going to redefine all of education in your classroom. So what can you focus on in your classroom? How much time do you have? Do you only have an hour to work on something? Make sure the solutions they're coming up with can be done within that hour. And we usually start a Kaizen event, I'm sure most people, with a charter that talks about what's the problem, what's in scope, what's out of scope, what types of things are our boundaries that we need to work within.
Very good, thanks. I don't know was there anyone else that wanted to come in or chime in?
Any audience members have a question? Anyone? All right, I have a question for you guys. Heather, we'll start with you. What was your earliest experience, or is there someone in your life that sparked your interest in STEM? What was that sort of, Morgan talked about a little bit, Shannon talked about how the employees at IBM are kind of sparkling afterwards, but from your perspective as a person who is working in the field, what was one of your earliest experiences you had, or is there someone along the way that really sparked your interest, and what was it?
I was thinking about this because I know you guys might ask a question like this. So my first experience is the one that I can remember visually was, I think I mentioned earlier, taking a tour of a factory, and it was a bubblegum factory, and we also happened to tour the Parker Brothers. So I got to see things in action, see what was going on, watch the equipment, watch the process. So that really sparked my interest. But then following that, too, I think it was about probably 2 years later, I had a fifth grade science teacher that was so much energy. Just loved going to his class. He's very exciting. He talked to us down at a level that kids could relate to. He was very animated with his hand motions, did a lot of experiments, would take us outside and show us things. And that just got me more and more curious. And I think that's where I learned the passion for maths and sciences.
Great. Yeah, that's one of the things we've talked about in these sessions is that the one thing we have, and someone had mentioned this on the panel, you start with what you have, right? And what we have every single day are naturally curious kids. And it's amazing. They can run out of it at the end of the day, but they show up the next day, that they're full of curiosity again, And they keep coming back, curious and curious and curious every single day. So it's really incumbent upon us to tap into that. Shannon, do you have a crystallizing experience along the way?
Trying to think. So I'm in a different field. I'm more towards the communication side of this. But coming to Abiomed, I always had an interest in science. I remember simple projects like lighting the light bulb, connecting all the wires to the batteries. Was always something that stuck. And I actually went in, I did, biology. I loved biology. Did AP Bio in high school, went into college, and got into the core curriculum. I went to a Jesuit university as well, and they wanted to create the well-rounded student, and I strayed from science, probably because the core curriculum, the teachers knew, the professors knew we were there because we had to be, and they weren't as enthusiastic and passionate about what they were teaching because probably most of the students were sitting there, reading something else, So I kind of strayed from that, but coming to Abiomed, I've had the ability to learn more science than I had imagined, and I love it. I've had the opportunity to go in and see how our product is built and see and appreciate each member of our force and seeing what everyone does. I think I've become more of a well-rounded employee because I've been at this company and learning about every aspect of the company and how this product is made, how it's used, and the end result, and it's wonderful.
I did not have a early defining experience. It happened to me in high school. Physics teacher, just classic, good teacher. But I want to say why I didn't and why that's important to me. And that is, you mentioned that kids are naturally curious. It's an axiom. It's certainly true. And John mentioned he hires for curiosity, perseverance, and passion. What I want teachers to be doing for my neighbors' kids, for the kids who are recent immigrants, for the kids who are troubled, is to take that curiosity and help them find their passion. And if they have their passion, the perseverance will come. And then John will be eager to hire them. And the way to do that is to expose them, I think. So I'm going to say, leverage their curiosity. And what I did not have, so I'm a first-generation college kid, and so I did not have the experience that my classmates did when I was in elementary and high school. I did not know the greater world out there. And what your kids need to understand, well, I'd like your kids to understand, is how fortunate they are to be growing up in Boston. Wherever they're from, wherever their background are, however troubled they are. It's such a dynamic economy. There are so many smart, educated people here. One of the reasons I love living here, you just run into the most interesting people doing interesting things. And so certainly you can talk about the experiences through the visits you've had, and I welcome kids to our business. Talk to me later, whatever, and go to the other ones. But also what I don't see enough of is leveraging the parents. I would think in the time you have, there's got to be some time to bring parents of all backgrounds, whether, like my parents, my foster father picked up garbage in the park, so he's garbage man. Bring them into the classroom, and what's their life like? Bring a lawyer in, bring a doctor in, bring a physicist in, an engineer, whatever. Expose them to as much as possible so that even if they don't find their passion as an elementary student, they've got the background, they've got the diverse experience to do so later. I'll leave it there.
Great.
With respect to an early influence, my dad was my early influence. I grew up in a family of 6 kids. I was number 4. And around the dinner table every night, didn't matter. My father would basically query us, rapid fire, not just about multiplication tables, addition tables, but anything that's happening in the world. And it enabled a couple of things. One, it helped the curiosity that Scott was just talking about, because we were able to hear from 5 different siblings who were in 5 different grades, ranging from 3 years older to 8 years younger than me, what their world was like and what they thought about it. And the second thing was, for whatever reason, at Woburn, one of the things we always did every year was a couple of times go to the Museum of Science. And I would get lost in the exhibits. They would have to come find me. And Literally, they would have to come find me. And that's what really triggered my interest in the natural world, especially the planetarium, which kind of triggered my interest in sciences and physics and astronomy. But one of the things I wanted to comment, I got a chance earlier before. I understand all the time constraints that everyone has and the Kaizen question about breaking problems down. But one of the things which I think that it's possible for you to be able to do is to blend things together, actually. I was at an initial management training seminar, this is 25 years ago, and they broke us into teams. We didn't know anybody else in the room. Had never met anybody before. There's 25 people in the room, so we broke into 5 teams of 5, and we were given an assignment that basically said, you've just crash landed in the desert. Here's what's left in the plane that didn't burn up. What do you do? Rate them in order of priority. Why? What would you do with all this stuff? And one of the things it did is it enabled us within an hour, literally within an hour, to learn to prioritize together, to get the inputs of everyone on the teams, to determine how to interact together. Because as I said, we'd never met each other before. And at the end of it, you had to present to the remaining groups why you did what you did. And I think that similar type things could be done with the kids in the schools. And you can pick things from the news today. Global warming, obviously, is a big hitter in the environment right now. Literally last night, myself and one of the other engineers, at like 6 o'clock, we were talking about global warming just because it was something that was interesting. And we wanted to know if the ice sheets in Greenland melted, what would happen? You know, because there's a lot of rhetoric and alarmist views out there, but as engineers and scientists are like, well, let's figure out what really happens. And so we went into Google, and every kid knows Google, and it's a great tool. And we figured out how much ice there is in Iceland. And since Iceland is land, it's not floating in the Arctic. When that ice melts, it has to go somewhere. It has to go into the ocean. And so we calculated how much water there was and how much water there is in area of space there is in the Earth and how much difference there would be in the sea level height of the world if it all melted. And it's a lot. It's like 24 feet. So anybody who has coastal property would now be underwater. But one of the reasons we did that is because we were also thinking about ways we can impact the economy to help prevent global warming while also spurring the economy. Just last week, I sent a letter to Elizabeth Warren with a suggestion for her to work with her colleagues in the southwest of the United States to try to find a way to implement on a commercial scale solar power at rates that would then be economical and lower than the ratepayers are paying in California today for the electricity. And it also would eliminate the need for about, I think it's 600 million metric tons of CO2 into the atmosphere every year. It's a huge number. And it's a similar type thing at a much smaller level, I think could be done with the kids. You could look at, everybody is hearing on the news about global warming and what it could happen and what could happen to, especially Massachusetts, you know, we have so much shoreline. And devise some very small discussion point and as a team, break into teams and give each team a certain segment of the problem and say, you find out what the issue is, you find out what the next step is. And one of the things you'll find is they will work together as teams, and then you have them present reports at the end. They don't have to be written. They can be, but the comment was made about oral. Oral is really critical. Most of the time, all our 80% or 90% of our communication is oral. And so if the kids can communicate orally, they're 90% home. And so I think that's a way that we can actually help spur combined thought and as well triggering additional work in their curiosity, working with real-world problems today.
And John, that's one of the things we talked about. Chris will get your response in 1 second, and then we have one final question for you. But that's one of the things we talked about today. That we watched a video this morning on that CAPTCHA technology, C-A-P-T-C-H-A. It's when you have to write in a little code when you order tickets on Ticketmaster or on your own website. You always have to enter words into a computer program to authenticate that you're a human being. And the project around that, it's called reCAPTCHA. And the gentleman and the team that's working on that, what you're doing when you do that is you're translating books. They've taken, they've video image the books, older books, into the internet. And these are words that the computer can't read. And so you're always given a word that's a normal word, and then a word that's one of these words from the books that can't be read. And so when you try to authenticate it, after 10 people have kind of agreed upon, like, that must be the word, that becomes the word. And so every time, they've taken, we're basically taking 2.5 million books a year, I think was the number, and in 10-second increments, this 1 million person workforce or 10 million person workforce, whatever the number was, in 10-second increments, we are totally making books electronic and available online that otherwise could not have been read. So it talks about what you're saying and sort of bringing it down into incremental chunks. The next project of this guy is he wants to translate the entire web into different languages. And he figures with a certain number of people, he can translate all of Wikipedia into Spanish in 8 hours by just having people do little pieces at a time. So it kind of strikes upon what you're talking about. Chris, an experience along the way or a person along the way that sort of sparked your interest in this whole thing? And then just so the panel knows, the next question is the last question. It will be a yes or no question.
I'll keep it brief. My interest in science came from grammar school, science projects from the 7th grade level, and my dad. My dad was an engineer himself. He was a civil engineer, did airport designs for a while, and then he decided that he would help design a wastewater treatment plant. So taking me to a wastewater treatment plant convinced me not to become a civil engineer. So I went into the mechanical fields. In any case, one of the people that actually fostered the curiosity was my older sister. She was the one that always said, hey, why don't you try this? Why don't you try this project? And she'd walk away. And he worked a lot, so did my mom. And she was the one that kind of fostered a lot of creativity, experimenting, trying different things. One of the reasons, some of the projects, took first prize is because she kept questioning, well, maybe you should try it differently. You have that ability here. And one of the themes I think coming out of the folks here from the industry is the fact that it's ownership, and it's part of a fabric that you want to build in the country again, which is job creation. One of the unique things that I think all of us share is the fact that we build most of our products here and ship them overseas. We keep these jobs are here again, as we talked about at the beginning of this whole thing. So having people have ownership, having students at such a young level say, hey, I went into that factory as a kid. That would be great to see that happen again. That means a lot. Or I did an experiment that we took from one of these other places locally in their neighborhood and know people that work there. It's important. It built it with us. It built it with me at Raytheon before here, and at the time was Avco down in Wilmington, to stay in the region and contribute back to the communities. So those are some of the things, the reason why I get involved into this. So,
thank you. So just to be totally upfront, this next question is a complete setup, but it's only a yes or no answer. But I'll be completely upfront, and I'm going to totally put you on the spot. But anything I read about leading a discussion board panel is you end with a yes or no question, so it can actually end when we're supposed to end at 2 o'clock. So with all that said, and being fully transparent on the question I'm about to ask you, John, I'm going to start with you, and we'll go right to left. Is Analogic willing to continue its partnership with STEMsquared as we move through the coming months?
Yes.
Great. Priscilla, Gordon College.
Yes.
Morgan, Applied Materials.
Yes.
Pam, Manchester Essex.
Of course.
Shannon, Abiomed.
Yes.
Heather, Verify.
Yes.
Yes. Chris, Excelis.
is the mic working?
It is.
Yes.
Excellent. See, we got them all on camera, too. We got you all on camera. So we can't thank you enough. This was awesome. I mean, I don't want to speak for the group, but I see some nodding heads out there in agreement that this dialogue and this conversation, this is only going to serve to continue to keep the conversation going and improve what we're trying to do at the elementary level, which will ultimately improve the middle school level, which will improve the high school level, which will improve the workforce, which will improve our employment as a country. So, again, thank you all very much. Pam?
But certainly not excusing students or making excuses for them in that case, kind of giving them the out is that's one method to at least begin down the path of building that muscle. It's not an option, right? And I think one thing I heard from the panel across several folks was that The technical skills get you so far. And the only thing that gets you the rest of the way, or some people are even saying most of the way, is those soft skills. It's that perseverance. It's that willingness to step up and say something, to disagree, to push back. Isn't that interesting? In a job interview, if you don't push back, you're not the best qualified candidate. If you come in overconfident, you've probably got some arrogance issues. That's interesting. Because we all encounter those sort of students in our classroom. And if you're in a school where you're maybe somewhere in the grade progression where you get to watch that student progress, those sort of things don't necessarily disappear, do they? What other things? Anything else? Yep, in the back.
I think it's important to recognize failure
Mm.
positively, rather than when someone talked about learning more from mistakes. Some stress on getting things right, and I think we need to find things and take the risk, learn from what doesn't work.
Mm-hmm. Learning from what doesn't work, failure is okay. That idea, the Kaizen event, so you can go back and look that up if you want, but the concept of getting all of your process owners, the people who own, in your case, you are a process owner in the classroom, you own the process of teaching these students. So when you get a mandate that's not informed by the process owners, these guys would never go about that, solving the problem that way. And to get to the root issue, if the root issue comes from a dynamic that's in the classroom, that's an important piece. But there's also other process owners, right? Like they were saying, finance people, this and that. Well, guess what? Our principals, our superintendents, all these other people are also process owners. Really interesting. And it's interesting that parallel between the success and failure, even when you start to, in Massachusetts, you look at the school of accountability structure and the way some of that reorganization goes about, have to wonder how much of this is part of that process consistently. I saw a couple other hands in the middle here. Yes.
I have a new thing to think about regarding test scores, because I'm concerned about the amount of testing and how it's getting our curriculum away from hands-on exploration. But the idea that those who do well on those tests show a certain amount of certain self-confidence and competitiveness, that's another skill. And so then it makes me also go to the flip side of, so how do I help those students don't do well and need those extra boosts, and have the scores not reflect on the ranking of the students, but also not necessarily my ranking as a teacher, because I may be working harder with the folks who are not going to do well in the test. Because eventually, I'm hopeful they'll develop those skills.
And when you can almost imagine your students in one of these group interviews being given a problem, and the boisterous kids, the confident kids being the ones that have all the answers, and other students not putting anything forward. So that can play out in a real life situation in an interview at Analogic, or it can play out in your classroom over and over again, where instead of that person ending up at the back of the pack, you can control, sure, lots of great ideas from you, but I want to hear what some other people have to say. I'm really interested in what you have to say, and you have to say, and you have to say. Because in a very clinical sense, we all have something to say. We have some ideas, and right or wrong, or true or false, or whatever it is, it has value. And that's an opportunity that we have in our classroom, that once students leave our classroom, we talk about when does it really count. I remember, this really counts, high stakes testing, every day really counts, actually. Every minute really counts when you think of the 10 seconds, right? 10 seconds really counts. There's a lot of opportunity, and I thought that it was also very interesting that, I'm not sure if it was the same gentleman, brought up the idea that it's not so much doing more, it's doing more with what we do. That idea of what we talked about earlier, the ELA math sort of crossover, reforming the things that we already do to make better use of the time. So a couple other hands, and then let's see, I haven't. Tammy.
Well, just to bounce off what you were saying, but something that did resonate with me was how many of the panel members are talking about communication, how important that is in today's world, and
Yeah, yeah.
They're so excited because that's that step that they can see where it all comes together, how all this stuff is playing out. And so I just love how willing they all were to, that. So hopefully we can foster that.
That's great.
Well, I think that to me was, I think John mentioned that. It was great. I know I said it when the discussion was going on, but him mentioning thinking, right? And then to hear the communication part of it as well. I think for a long time in industry, I think it's always the hard skill, it's always the hard skill, it's always the hard skill. And I don't think these are soft skills at all, that interpersonal, that ability to communicate, that ability to articulate what it is that you have learned, right? That's the best teaching there is, maybe something else. So when we get kids to think in that way, that's using practices and processes and things along those lines, and couple that with the communication, very encouraging.
He also said when we were at Analogic, someone asked him about hiring someone who is that kid that we all have, who is unbelievably smart and gifted, but only looks at his shoes. He was saying, there might be a spot for that kid, but there's more spots for that kid who can also talk, who can also communicate. And that piece of that is so important for those kids that we've already identified and self-identified as the tech kids, but can they communicate?
Okay.
Because I think sometimes I have in my head the khaki and sneakers mentality, right? Or that Google guy who's bouncy ball, but might be a little awkward at the dinner table. I think that that's engineering and that's science. And I have to think that, especially in a high school level, bought into stereotypes that they're looking for. They may see this. I think bringing into these companies, identify with, hey, that person looks just like me, and I might not be a rocket scientist. A lot of kids associate science with the need to be brilliant and ingenious. That you can just be us. That there might be a place in science for you, and that it's not this small top of the pyramid pitfall opportunity. Actually much broader than I think I realize. We're in a very different group. We've had a little bit of exposure. That maybe the kids don't realize. And so it's not just for kids who might play Legos, like Minecraft.
Right.
But that might be what kids internalize, that's who goes into science.
The optics of the situation, I'll compare it to when your students see you at the grocery store in jeans on Saturday. Oh my God. Right? It's that whole sort of, I have this image of a teacher in my mind as a student, and I didn't know they grocery shop. Well, how do we eat? Well, I don't know. But I think you're right. I think changing the imagery of it, and one way to do that is those site visits. I think I said this in one of the earlier sessions. I remember a couple of years ago, I Googled engineer. Because I was curious, what would come up on Google Image? That sort of same sort of mentality of what would be the first thing that came up? And it was Mickey Mouse and a train conductor hat, right? That was the first thing, engineer, training. And I'd be curious if you Google image engineer now, what would be an image to come up? I would hope that Mickey has moved, a little further down the chain, so to speak. But I think you're right. And one way to change the optics for the kids is to get them out in the field and have them see these people who are doing these things and working in these companies and solving problems and asking questions and identifying problems. And yeah, they're not the image of that person that we may or may not have in our mind. Want to be respectful of time.
Yes. So we have about 5 minutes left. So I think we should probably at least go through the last couple slides if we can. And if you have to leave, and I'm sure many of you do, the staff will be up at the desk, and I'm sure folks have people to pick up and places to be. But I want to respect the reason you came here as well, and try and just go through couple last slides, shouldn't take too long. And unfortunately, we didn't get to workshop those lessons today. What we'll do is, so that we get more people with lessons, the next session, what we'll do, if you bring those back, we will work through those. We'll make that a priority for the opening because we're going to be connecting that.
Is that something that you would value and you'd like to do? I mean, we want to make sure we want to use your time wisely. We have one session left. So as we plan that session, is that something that you'd like to do, is take maybe a lesson and using some of the things that we've learned here today, develop and grow and add those processes and practices maybe into a lesson that didn't currently exist? Just do it by a sort of dipstick, yes, maybe, no. If yes is up, maybe is middle, and then no is down. It would be part of the session, it wouldn't be the whole day, it'd be maybe an hour or so of the session.
For a half hour. Okay. So we'll work that out. So, okay. Great. I guess so for those of you who are, so in this PowerPoint will be online, so STEMsquared.org, the website, STEMsquared, spell it all out, .org. The PowerPoint, all the other PowerPoints are up there. The resources will be up there, so if you want to go through and click back over, or if you're going to share with a colleague or your school, whatever, go for it. Just some quick thoughts. So before we left off for lunch, we were talking about UBD, and we had gone through the 3 stages. The first stage being determining what your focus is based on standards, practice, and process. Second stage, determining the evidence, so that's the assessment tools. How are you going to collect information about those processes, practices, and standards? And then the third part, how are you going to get the students to interact with them, practice them, and what are the materials around that? So moving forward, I just wanted to kind of take a look at what this looks like at different grade levels. So one piece, so grade level 2, here's some standards from the current Massachusetts pre-K 2 standards related to the solar system. So one tactic to build on what's been talked about here, if you want to address multiple areas of content at the same time, you can do that, kind of killing 2 birds with 1 stone, but you got to group the standards. Okay, so these 4 standards are all grouped around doing solar system in 2nd grade. Okay, dealing with solar system. So objects and materials that are solid, liquid, or gas. Solids have a definite shape. Liquids and gases take the shape of their container. Standard 3, weather changes from day to day over the seasons. Standard 4, sun applies heat and light to Earth and is necessary for life. Standard 5, events around us have repeating patterns, including seasons of the year, day and night. So you can see how this all plays out in the context of a solar system because these celestial bodies are all orbiting each other. They're rotating. They're actually different states of matter. Terrestrials are solids. Gas giants are either a liquid or an ice. Those same standards can be articulated into a construct with the 3 dimensions of the next generation science standards. Okay, so that's what we're looking at here. Is dimension 1, the science and engineering practices. Dimension 2, cross-cutting concepts. Dimension 3, Earth science. So same unit is meeting the goals of the current mass frameworks, but also the next generation science standards. It's a matter of how you frame it. Okay, so this is. We would be going through this in our process of identifying the standards, and the practices would be how we flesh those out, and processes would be how we flesh those out. But then how do you take that and bridge the gap to ELA? So in this case, grade 2, we may be reading aloud something like the Magic School Bus Journey Through the Solar System. And so these here are Common Core ELA standards related to reading that book. And actually, this is just 1 page. There's probably 3 pages worth of ELA standards that relate to this. So things like identifying the main topic and recalling details of a text. So we'd be questioning students around, what's the main topic of the book? What are 3 key points? Asking and answering questions about key details in the task. So is there life on Mercury? What is an asteroid belt? You could even go further. You could be asking about, because the Magic School Bus, it's bridging that gap of fiction, nonfiction. What did the bus become? Why were the students transformed to have to wear the astronaut suits and helmets and things like that. Describing the connection between two individuals, events, ideas, or pieces of information and text. How are water and life connected? So we're talking about a solar system unit, but actually, and I mean, now we're talking about an ELA standard, but this actually starts to border on to water cycle. How are water and life connected? And so in this book, they're learning living things need water to survive. Water's a major part of the search for life. If there's no water, most likely there's no life. So you could see one after the other. If you go into grade 3, so kind of that idea of weather and water cycle, a bunch of standards, ELA kind of on the left, math on the right. They're not always, it's not, unfortunately, all of these things, there's no clear template in the sense of, oh, I got to do 5 from ELA, 5 from math. It's a function of what you're trying to assess with that unit. But you can see here, even in 3rd grade, dealing with weather and water cycle, if you're doing it in a hands-on context, you can be incorporating understanding fractions, explaining the equivalence of fractions, telling and writing time. If you're doing a timed experiment, that's actually a math Common Core standard. Same thing, measuring matter, grade 4, so you can see applying area and perimeter, using 4 operations to solve word problems, liquids and volumes. All of these things are math standards that are also applicable within a STEM unit, but it goes the other way around. If you're doing a STEM unit, you're actually hitting these math standards. So it comes to that, if I'm going to do an hour of this standard over here, and I'm doing an hour of this standard over here, you have to ask yourself the question, do I really want to do 2 hours, or is there a way that I can use the science to achieve the math? Kind of another way, so what I'm showing you right now is sort of a way of documenting, considering and documenting. There's another way to kind of achieve this. So if you look at, this is a Common Core connection from grade 6, one way to look at it. So the ELA standard is reading standards for literature, 6 through 12, craft and structure. Explain how an author develops the point of view of the narrator or speaker in a text. And I'm not going to read this article to you, but this is an article excerpt from the New York Times. And it talks about individuals who are building seawalls at the high tide mark. And the author goes through talking about after the storm, all of these people in the Hamptons are building seawalls at the high tide mark. And as a result of it, the waves are crashing and eroding the land below the high tide mark. And they're interviewing people who like to walk on the beach that don't live in the Hamptons. And they're saying, guess what? We used to be able to walk up to the high tide mark because that's the line, but now, because of the seawalls, which are perfectly legal to build, we can't access the shoreline anymore. And it's causing issues with the ecology and everything else. So we're going through and asking the purpose of the story. Are there competing points of view? What points of view is the author bringing to the text to balance? Okay. You can do a similar sort of thing. And these are, I'm saying grade 6, but you could do this even in 3rd grade. You just have to pick content that's in that, at that level. Math. So how many of us, you may or may not know, at the middle school level, one of the standards in science relates to topographical maps. So that's a geography connection, STEM connection, but it's also a math connection because if you think about a 2-dimensional map becoming a 3-dimensional map, those are closely interrelated with topographical maps. You can overlay a Cartesian coordinate system, and you can start to deal with applying and extending previous understandings of numbers to the system of rational numbers, and using ordered pairs, finding the location from the origin. And you can take the same sort of piece and go from a mythical map, like these mountains and towns, to something that's even within your town. One of the schools I was in, a while back, they had a whole painting of a town on the wall, and you could actually take a grid and overlay it on the town on the wall and say, okay, what's the coordinate of this hilltop and my house and your house and that sort of thing. So science lesson extending into math. The math lesson, in some ways, it's extending into science. And then the practices, if we go back to those NRC practices, which I'll just kind of zoom back to real quick. Sorry, many slides here. Here we are. Those NRC practices, so asking questions, defining problems, developing and using models. So in the case of finding the location between the two hilltops or the towns, you're developing and using a model for that. The Cartesian coordinate system is actually a model. And overlaying it on a two-dimensional map or a topographical map. Planning and carrying out an investigation. So we talked about the Pilgrim example. How would we investigate to find out if the quality of the soil was a reason for moving from Provincetown to Plymouth? Analyzing, interpreting data. So as you're doing that investigation, even that article from the New York Times, somebody went out and investigated these walls. And they're talking about the data, about the amount of erosion, the impact, maybe economically, the impact on access, the impact on the environment. That's ELA related, but it's also a STEM practice, analyzing, interpreting data. And so ELA and STEM at the same time. Constructing explanations and designing solutions. So here, again, you can kind of go back and I don't want to get too into it because of time, but if somebody didn't go and actually point fingers at the seawalls, you could approach a writing piece from constructing an explanation for why something is happening. Why are there's an interesting case in I think it's Yosemite where the wolves died off due to overhunting. There was something related to humans that the wolves disappeared. And then what they found was other animals started disappearing. And so you could construct an explanation or design a solution around what claims people are making in the media about reintroducing wolves. I mean, there are people that really believe that predators, like bears, you ought to be able to have bears crawling around the woods at Chabaco Lake. I mean, it's people believe this. Is that a convincing explanation? How is it being constructed? So looking at what somebody else has created and deconstructing it, it's scientific. What is the scientific basis? But yet that's an ELA skill. Engaging an argument from evidence, and I think you even heard this from the panel, and we've said this over and over, the communication skills, it's taking, again, an ELA skill, it's taking your opinion, backing it with evidence, and bringing it to the table. And it's interesting that I think John must be the one gets most quoted today. He said, did he say that 80% is oral? 80% of what goes on is oral, and that some people you offend by way of arguing your idea. But that's part of this process. So it's a STEM practice, it's a communication practice, and in a written form, it's an ELA practice. Using the data being a math standard practice. And then obtaining, evaluating, and communicating information. There's I think it kind of goes without saying, there's the communicating aspect is both math and ELA. Evaluating, just like that Venn diagram, evaluating it in writing, evaluating it in a graph, ELA, math, and obtaining the information is a data collection math standard. So those are all things to kind of keep in mind as you take your lesson and whatever you bring back for the next session, and I won't keep you much longer. Maybe look at it ahead of time and think about how those practices have an opportunity to play out in the content that you have, in the activities that you have. And if they don't, how would you change it? And so, sort of here, you won't be finding your team today, but thinking about going through the 3 stages of the UBD, starting with stage 1, not skipping ahead or going back, looking for the processes and practices that lend themselves, and then finding where and how and what needs to change. So forget about, you got to kind of throw the resources out. So if you're like, well, I've got my box of rocks, I've got to use that. Forget about that for now. If you didn't have to use that, what needs to change? Because chances are you still can probably use that, but until you consider what needs to change, you're not going to, sort of like some of the folks on the panel were saying, you might end up solving a symptom and not the real problem. And the problem being that the practices and processes aren't a part of it. That was the 10-minute quick version, and we'll pick up. Sure.